Okay, bye.
Veltech Multitech Cse! Salam matches!
विमल सर आमचं विमल सर
in rising every time we fall. A very good morning to one and all present here. We are so delighted to take this opportunity in welcoming you all to the International Conference on Internet of Things and Challenges 2017, organized by the Departments of Computer Science Engineering and Information Technology of Veltech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College.
The very logo of Veltech signifies the support and respect to all religions. We shall start this event too by invoking God. Let us all rise for the prayer song.
By lighting the lamp, I would welcome all the dignitaries to come forward for the lighting of Puthurukku.
Not knowledge or not facts, but of values. It is on occasions like this we get opportunities to explore our knowledge and understanding on recent advancements in technology. And here we have an opportunity for the same. First and foremost, it's my honor to welcome our Supremo, our founder chairman, Colonel Professor Dr. Vel Shri R. Rangarajan. With a strong sense of passion for education and commitment to build a better tomorrow, he has ensured the successful growth of Veltech Group of institutions. I also take immense pleasure in welcoming the pillar of support, our Vice Chairman, Dr. Sakuntala Rangarajan, who motivated and supported the growth of a successful paradise of Veltech. I welcome the man of distinct vision and the fountainhead of illuminating ideas, our Vice President, Mr. KVD Kishore Kumar, and our most beloved chairperson and managing trustee, Mrs. Rangarajan Mahalakshmi Kishore, who is an idol of knowledge and inspiration to all of us. It is our extreme privilege to welcome our most respected chief guest, Mr. Suresh Reddy, the chairman of CEO Lycos. Mr. Suresh Reddy is an entrepreneur and founder of two successful companies, USA Greetings and Lycos, formerly known as Vibrant Technologies. He is a specialist in online marketing and advertising, having more than a decade of experience. He has a commitment in building high-value businesses. Mr. Suresh Reddy has created a global network of trusted relationships with peer entrepreneurs, corporates, partners, institutions, and the media. He also worked in various roles across different industries in Fortune 500 companies such as Caterpillar, Chrysler, SBC, etc. It is a great pleasure having you here, sir. It's a great pleasure having you, sir. We extend a hearty welcome to our principal, Dr. V. Rajamani, sir. Welcome, sir. And I also welcome Dr. V. Parthasarathi, Director, Campus to Corporate of Veltech. Welcome, sir. I also welcome and take immense pleasure in welcoming Dr. U. Chandrasekhar, Pro Vice Chancellor, Veltech Rangarajan, Dr. Sakuntala, R&D Institute of Science and Technology. Welcome, sir. Finally, I also welcome the HODs, faculty members and students of Computer Science, Engineering and Information Technology Technology departments of Veltech Multitech Dr. Rangarajan, Dr. Sakuntala Engineering College. Last but not the least, without whom the event is not possible, I greatly take the pleasure to welcome our participants for the International Conference on Internet of Things and Challenges 2017. Here we have our faculty, Ms. Mary Judith, to deliver our chairman's biography.
Shri Dr. R. Rangarajan, the founder and chairman of Veltech Group of Institutions, has a cherishable memory behind his success. Setting high standards and love for tireless hard work have made him to swim against the turbulent tides with ease. As a man of steadfast values and belief in excellence, it is no surprise that he consistently topped his class. By his absolute perseverance, he rose from as an engineer in TNEB to a towering industrialist. After graduating with honors in electrical and mechanical engineering, Dr. R. Rangarajan earned a master's in automobile engineering. After a short stint in TNEB, he established manufacturing facilities to produce spare parts and rubber parts for automotives as original equipment at Ashok Leyland. Having emerged as a successful and prosperous industrialist, he felt the urge to contribute something to make India stronger. He realized that creating knowledge assert would propel both social and economic development. Hence, he ventured into the educational sector. Being supported and motivated by his wife, Dr. Mrs. Shakuntala Rangarajan, he started a school in Avadi, followed by 3 engineering colleges, 2 paramedical institutions, and an arts and science college in a matter of 10 years. With a strong sense of passion for education and commitment to build a better tomorrow, he ensures overall development to the students. Since 1990, the cluster of educational institutions was established under their trust in Avadi. Dr. R. Rangarajan was a syndicate member of the University of Madras and Anna University. Veltech provides access to high-quality, multi-purpose technical education without any barrier. As Chancellor of the University, Dr. Rangarajan instituted a ₹7 crore Veltech Mahatma Gandhi National Merit Scholarship to ensure that the poor students are benefited, yet the meritorious are not denied such access. The 7th Mahatma Gandhi Scholarship worth ₹1 crore were distributed to 119 students by Mr. Narayana Murthy, Chairman, Infosys. This noble vision has borne fruit by attracting students from across the country and students from every state. So far, more than 400 students have had the benefit of totally free education, boarding and lodging. Veltech institutions have a student population of 20,000. Inculcating the values of honesty, determination, discipline and dedication, Veltech engineers add value to our national progress. In order to ensure that every product of these institutions is industry ready, he has incorporated many novel and unique programs in the curriculum. By his personal intervention and perseverance, he has successfully penned more than 200 MOUs with reputed universities and research establishments all over the world to enable faculty and student enrichment by faculty and student exchange programs, dual degrees and interactions with more than 2,500 industrial establishments in India and China for compulsory industry internships for all engineering students. He has also arranged for placement with 306 companies. For this purpose, to make every student employable, he has built in a 4-year structured soft skill courses in the program. His aim is to build a highly enriched reservoir of managerial and technically qualified manpower. Industry-linked and industry-specific postgraduate programs with CDAT, SAIL, Tata Steel, TAFE and FCRI are some shining and successful examples. Realizing that the research and development in association with the industry is vital for achieving the mission, Dr. Rangarajan established an exclusive research park with over 80 laboratories to conceive and develop joint research between industry and institutes. Veltech is India's first university to set up a telecom center of excellence by the Ministry of Communication. In recognition of his outstanding contribution to the society and the nation in the field of education, Madurai Kamaraj University
you so much, ma'am. In remembrance of the International Conference on Internet of Things and Challenges 2017, I request our dignitaries to come forward to release the proceedings. Please, sir.
Sir, update. Sir, sir. அது வாங்கிக்கோங்க மேம் அது வாங்கி அந்த இதெல்லாம் எடுத்துருங்க கரெக்டாக சார்
Thank you all. I now welcome our respected chief guest, Mr. Suresh Reddy, to address the gathering.
So welcome to the IoT conference. I'm sure you're all excited to get started and start talking about what is going to happen in such a huge establishment. As I was driving from the hotel, I was just driving and driving. There's acres and acres of Veltech everywhere. It's very impressive. I'm an entrepreneur myself. Obviously, it's exciting to see somebody who can build something so large. So I think you should be very proud to be part of this great institution. So coming to IoT, before I start talking about IoT, I'd like to tell you a small story. Basically, some of you might have heard, it's called the cat and milk story. Basically what it is, there's this little boy who goes to visit his grandparents. And his grandma, is very happy, he's running around. So grandma has to go out for a while. And she has milk on the table. She tells the little boy, watch the milk. Make sure that the cat doesn't come and drink it away. So this boy is looking at the milk, and the grandma comes back. Then she asks the boy, what happened? The milk is gone. He says, yeah, the cat came. So she says, I told you to look at it. He says, yeah, I was looking at it. But the cat came, drank the milk and went away. You didn't tell me what to do after that. So that is the core of the difference between data and information and how you process the information. Let's say this same boy was given instructions. As soon as the cat comes, you press this bell like SOS. Then at least the grandma would know. Maybe she might not be able to take action. Or if this boy was given some alarm to press, then there would be a loud alarm and the cat would get scared and run away. And the IoT way would be to actually have a collar around the cat with a GPS around it to know exactly when it's coming in the territory. So that is how you actually see. That's the cat and mouse, the cat and milk story. I found it fascinating because it really highlights some of the core things in what all these sensors are sending. Just take for instance, the cat goes into the neighborhood house, it goes into the neighborhood, it walks around, I get so much data. I know where all it goes. But is that useful to me? What is the useful part? How do I take that? How do I assess it? How do I take the data and convert that into information? And what action do I take? So these are the three things I'm sure we are all very aware of. I just wanted to give a very broad overview. The idea here is the sensors prices across the world have dropped. And that gave birth to something called Internet of Things. So what is Internet of Things? So far when we say Internet, I would go to an ISP. I would take my laptop, connect through my router to the ISP and use it. That's the old way. And that's the user trying to learn the internet. Now the internet is all pervasive, it's all around you. So that fan can have a sensor and be connected to the internet, the light, everything, this mic, everything can be connected to the internet. That's how the whole paradigm shift is coming through. And what can we do with it? The ideas are plenty. The so many ideas that are flowing in the system, so many brilliant ideas that are coming up every day. It's amazing to see. It's like almost the early days of internet. I was part of the early days of internet when we started Lycos. And I know the excitement. And I feel the same excitement today. So it's completely the new, what you call Internet 2.0, if you may, in the generic terms. And broadly, there are 6 areas I would personally define. I'm sure if we go through your papers, there's so many other ideas that are popping up. The first one is, of course, smart homes, where your homes are all connected, and it's a convenience for you to go through your life without too much hassle. Take, for example, you wake up in the morning, you go into a shower. Every day in the morning, you have to adjust the knob, temperature, all those things, so that the water that comes out of the shower is based upon what you like. But if you had a smart shower in the house, you do it 2 times, 3rd time it would know. There's no reason for you to do it again and again. It's a very simple thought. Now I apply that to coming down, I have my breakfast, I get into the car. Before I come to the car knows I'm coming. And especially with warm weathers like Hyderabad and Chennai, IAC should adjust. I don't need to go in there and have a very hot car. It should be cool. It should be the temperature that I like. And I drive into the workplace. Every day I take my scanner and scan. It's illogical. The system should know. I just walk in, the door should open, I should go in there. So I can go on and on. Then I go into an airport. There are 4 lines I have to cross through. First to go in, then get my boarding pass, then again security, then in front of the plane. All these can be eliminated if there is a simple way for the system to know who you are and your security checked. That's it. Then it just takes away all this hassle that we are going through today, given the kind of world we are living in. So that's the whole idea behind what these little devices can do going forward. It's fascinating. The applications are enormous. Academically, there are so many things one can do. And this combination is just shattering all kinds of myths that some things cannot be done. It's just rocking the whole world at this point. In the same way, there is industrial IoT. There are areas where, like they say in Star Wars, in Star Trek, that no man has gone before, where little sensor can go into areas where no person or no eye can go in and tell you what's going on inside a pipe where the corrosion is going to happen. They can prevent major disasters, save so much money for the industry. These are just simple examples I can think of. Then get into agriculture. The farmers can know exactly the moisture that's there in the soil. That's a simple example. There are so many ways one can do. If you talk about smart cities, there is so much work going on in smart cities. It's brilliant. We are having issues right now. The biggest problem next generation is facing is pollution. Pollution in terms of air, water. So for example, Delhi is a big problem today. We're all reading the newspapers. There could be phenomenal solutions that can be put together if we put our mind to IoT. So these are some of the thoughts I had I wanted to share. And I would like to thank you all for putting up with me. And it was wonderful to be part of your inauguration. Thank you. Thank you.
Please come in.
All right. Thank you, sir. I also request our principal to hand over a memento. Thank you. Okay, we have come to the end.
On behalf of the Department of Computer Science Engineering and Information Technology, I would thank to our Chairman, Vice Chairman, Vice President, Chairman and Managing Trustee, Principal, Directorate Campus to Corporate of Veltech for a memorable presence. A big thank you to our Chief Guest, Mr. Suresh Reddy, and our keynote speaker, Mr. Swaminathan Venkatraman, who spared time from their busier schedule to grace the occasion and for sharing their knowledge with all of us. I also take this opportunity to express my deepest sense of appreciation to all the faculty members for their participants for making this event happen. Last but not the least, we are really owed to the Almighty to provide us such an opportunities again in future. Once again, thank you all for your presence. Thank you.
with that data there is a lot of applications that you can create. Now each one of us eventually has an idea of what is IoT, what does it really signify. So how many of you have an idea of what is IoT? Of course you have written papers around it, and I'm sure each one of you has a different definition of IoT. So how many of you here can actually tell me what you think is IoT? And we'll talk about how it is different from other things. Anybody in the audience? If you don't tell me, I'll have to pick people. So we'll keep this interactive. Anybody? Okay, give it to him. Give it to him. Yeah. So you tell me, what do you think is IoT? Anything. Don't worry about whether it is right or wrong. The best part about IoT is there is nothing about what is right, what is wrong. So what do you think is IoT? No? No idea? Anybody else?
IoT is like interfacing sensors, and what he said is smart city is like the examples for IoT, where we implement all the technologies together. Whatever it is, using wireless or wired or whatever it is, remote sensing, everything.
Why is it important to you?
It is important because it is a trending technology in the future, and as of now, it is a booming technology. We have more scopes there. We can innovate or find everything using Internet of Things.
Still, why is it important?
Sir, it has vast application in day-to-day life, sir. It's making it easy, sir.
Okay, so it has, one answer I get is it has application in day-to-day life. It makes it easy. Okay, what else? Well, why is it any different? Yeah.
Because it saves our time, and there is no need of we are going every time, we are doing it daily life, so there is no need to make us
Okay, yeah.
in daily life we are doing it again and again, so there is no need every time we go and say do this. We have to make it ready. If you go in front of door, it must automatically open it because it's going to.
So automation. Okay,
automation.
So your answer is automation. Anybody else? I will come to you. All of you behind. I will come to you. So, what is your view of what is IoT? The problem with all these kind of high-tech technologies is we tend to associate it or stereotype it with a particular thing that we know rather than what it really delivers. Right? So unless and until an IoT-based solution delivers a value system to you, it is not a cost element. See, at the end of the day, anything that delivers value has to be measurable, isn't it? If you are not able to measure it, then there is no use of the technology. There is no use of that particular piece of body of work that you academically say is important. So at the end of the day, you have to be able to measure it. So if you take IoT, you have to first think, where is it used? Then you will think about how is it used. Then you will think about what makes it usable. Right? If you don't ask these questions, the mystery around IoT keeps building. Right? Everybody thinks it's a big thing, it has got, like you said, all technologies around it, and I have to read more, I have to get myself ramped up on too many things. The point is not that. The point is we are starting in a wrong basis. The technical basis always has to come based on what use cases, what kind of use you are going to put that technology for, right? So how many of you here program? How many of you do programming? Okay. So, Lisa does programming. Anybody else here who does programming? On what language? Sorry? What language?
C++.
Okay, C++. Who's Python? Who said Python? Huh? You have it in your academics, right? So what are the language? Did you know that the language that is, I was talking to some of my friends here and colleagues here yesterday. There is a language called Go. How many of you know a language called Go? Why is it different? You heard of Go? Who else has heard of Go? You heard of Go? Yes? Very good. Why is it important? Because Google did it. It's important. Huh? Why is it important? Have you ever asked, the question that comes to me is that you all know IoT is trending. I'll show you some other very interesting trending topics. No? I will show you. Okay? But first, I would like to really understand. It's very important you share with me what you think is IoT. Don't worry about whether it is right or wrong. Nobody has figured it out. Trust me. If one guy would have figured it out, he would have been a millionaire by now. Nobody has figured it out. Everybody is still attempting to figure out what is the potential of IoT. So IoT is like that, how do I say? We call it in the industry, we call it as an organizing vertical, where you get organized. So that you have people, so like for example, this conference that you're having needed somebody to organize it. It had people who were coordinating it. It had money actually budgeted against it. So because there was a conference, there was money allocated. So many companies today do IoT because only if you say IoT, you will get money to do something, for example. But at the end of the day, they are not implementing IoT. They are implementing a particular use case. Like for example, whatever Suresh was mentioning, he mentioned a couple of industries, retail, buildings, smart workplaces, smart cities. These are all use cases. To implement a smart city, you take the help of the Internet of Things. To implement smart healthcare, you take the help of Internet of Things. So Internet of Things has got different forms and flavors and slices. So nothing is the same, which is why what he said makes sense. That there is a lot of technology, you can pretty much use everything. Why? Because each use case has got different drivers. Each of those use cases, since it has got different drivers, it employs different technologies. You understand? So that's how IoT is. So IoT is like a myth. It's out there. But what it really is delivering for people is simplifying their lives, automating a lot of things that would have been done manually, like what they said. But more than that, it is starting to deliver value where humans and inanimate objects, non-humans, are becoming or coming online. So for all of this to happen, that fan to have its own sensor, this AC to have its own sensor, it's fine. But then apart from sensor, it needs to be able to communicate. It needs to be able to come online. Which means like how I am talking to you people, I should be able to talk to those devices. Isn't it? That's the first step. First step is communication. To get data, to send data, whatever. And data information will come to a little bit later. Right? So, to communicate to somebody, what is most important?
Medium of
Very language, medium of communication, anybody else?
artificial.
Well, come forward. No, why are these? Please come forward. I cannot walk so far. Come forward. Please come forward. So, artificial intelligence. Somebody said artificial intelligence. Yes, good. Next. We'll come to artificial intelligence. What is normal intelligence? What is artificial intelligence?
Sir, artificial intelligence is so that the machine can think by itself.
Machine can think. That is dangerous, no? Machine can do what you want it to do without you being there is artificial intelligence. Can you keep it like that? Is it better? Because if it starts doing by itself, we are in a bit of danger, right? Thank you. Anything else? What did I get till now? Someone said here? Language. Someone said here communication. I'm asking for communication. What do we need?
Medium of communication.
Medium of communication. It's language again. Okay, language. What else? Anybody? Should I come there? Protocol. Correct. Protocol. Give structure to language. Correct. Without that structure, it will be like this. No? You can't understand. That's right. Yeah, protocol is important. Without protocol, connectivity cannot happen. Okay. To connect to somebody, what do you need?
Address.
Address. Without the connected object having an address, can you talk? Hello, if I say, whom is it? Right? You need to have an address to communicate, right? So, what is the problem? What is the challenge for communicating with objects? See, what is the title here? Prepare for billions. So, in IPv4, everybody knows IPv4 to a little bit extent? Yes? What is the problem with IPv4 when we handle billions of things?
Shortage of addresses.
Shortage of addresses. Which means that You cannot address fan, light, all these things with IP4. Understand? If you don't address, you cannot communicate. If you cannot communicate, you cannot collect data. If you cannot collect data, you cannot get information. If you cannot get information, you cannot build application. If you cannot build the application, you cannot monetize it. If you cannot monetize it, you cannot make money. Finish. You understand the cycle? You need to understand this cycle to use technology. First of all, don't get enamored or don't get, what's the right English word? Don't get actually petrified or don't be afraid of a language or of this IoT environment. It's nothing. First, make sure you get this. Unless you understand where it can be used and why it is important, it's meaningless. There is a lot of hype now. So when you have time, you go take a look at something called as the partner hype curve. Okay. So what it does, don't worry, it's not specific to IoT or anything. There is a hype curve always. The hype curve starts at the bottom, goes up like this till everybody is talking about it, but nobody knows what it is. And then when people start realizing, oh, this is this much only, then it will start slowly coming down. You got it? Then people will understand and it will come to a place where it will start giving really productive results. It's called plateau of productivity. So the hyperbole that goes. So it's very important to understand that, IoT is currently a space where we first have to solve the problem of addressing. Okay. So if IPv4 cannot do addressing, then what do we do? IPv6. Very good. So that's the starting point. Clear? So when you prepare for billions, you prepare for connectivity to so many connected objects. So first we will talk about demystifying what is IoT, what you should be aware. We'll talk a little bit about representative IoT applications. And as I go through it, make sure your thinking is starting, because we will finish the session with what you think you can build as IoT applications for your college. And each one of you must give me one application. So there are so many people here, I will make sure everybody tells one application at least. Okay? So we're going to start with the fact that when you prepare for billions, these billions are basically objects that are coming online. Examples of objects that are coming online that you see. Sorry? Somebody said something? Mobile phone, one of the biggest objects that come online. Next. Actually, this is your mobile phone is the biggest IoT device in the world. Nobody realizes this. Everybody thinks IoT is something different, no? But this has the highest number of sensors that you can find. This is the single biggest IoT device. So how many of you use your mobile for, apart from watching videos and listening to music? How many of you people use it while you jog or while you cycle, or anybody here? While you play? Actually, the highest usage is as a fitness device. If you because you can pair it with a wearable, you can use it as a wearable itself. So this is the highest actually. And people don't realize it. See, this is the first stigma that you should move out of IoT. IoT doesn't mean that there is something like a box out there. It is not a one single box. It's a phenomena through which objects are beginning to communicate, and because they are able to communicate, you are able to build interesting applications. Clear? So let us now first say that I am not afraid of IoT. I know what is IoT. It's just that there are more gadgets which are coming online, which are IP addressable. And because they are IP addressable, I can basically get data from them, talk to them, and it creates a new application space. This is IoT. Any other examples of what you see as IoT in your life? Phone is one example. Next, what else? Huh? Sorry? Sensor to doors. Okay? Wait. When we are taking a picture, there is an image sensor. You see, suddenly IoT went back 20 years, 30 years. You see the problem? No. You're right. There's nothing wrong in what you say. But what suddenly happens is your definition of IoT is only with the sensor. And I'll tell you why it is important later. Keep this in mind, I will tell you later. There is something called edge computing. There is something called computing in the cloud. There is something called computing on the server side. In your case, your camera didn't send data anywhere. Whatever it had to compute, it computed within the camera. There is nothing to say it is not. That's what I'm telling you. There is no stereotype to IoT. You understand? So in your case, the camera actually sensed the person, calculated the distance, took the aspect ratio, took the picture and stored it with it. Whatever processing it had to do from computer vision perspective and so on, it did within the camera. So the entire compute was on the device. This is called field IoT. It is in the field, for example. Which means now people are beginning to say that, oh my god, I should not say IoT is just sensor going, sending information to the cloud. There could be a case where sensor is actually taking information and it's using it locally. There is one more place where in your house there are different sensors which actually connect but do not talk to the cloud. They talk to a central gateway which is there within your house itself. Because your information about your house should not go to the external world. So that's called edge, processing at the edge. Then there is processing in the cloud. Anything else? Anybody else? Wearables. So wearables is one smartwatch, right? Apple Watch or Android Gear, Samsung Gear and Android Wear and so on. Anybody? Google Glasses. Okay. I'll wait. Somebody else. Give me an example. Very good. Give me an example. Why do you think? What? For what?
If you move towards that and it starts working on like the gate or let's go.
It opens automatically. Sensors and opens. Okay. Excellent. Anybody else? Talk to me. Please, will you talk to me? Talk to me. Tell me. Give me an example. Sorry. Give me an example. Don't worry. No ideas. Anybody else? There is lots which you can actually see. So let us say, by the end of this session, we will talk about in this campus what you can do. I'm going to ask you that. So please be ready. In this campus with IoT, what can you do as applications? But why don't you think about how many of you are from villages who have a village background, who have agricultural background? Have you ever thought how IoT can help in agriculture? Have you ever thought of it? How many of you here come from healthcare background? Parents who are doctors or... Yes. How many of you come from a workshop, industry kind of background? So today if you see, how many of you have come from a background where you do retail business, where you have shops? Anybody? Did you know that the industry that actually has the highest number of use cases for IoT is retail? Did you know that healthcare is also very high? Did you know that agriculture is a big thing for IoT? Have you ever thought like that? Because you all see IoT first. The usage behind IoT is never before you. IoT is blocking your definition of what it is. In agriculture, for example, how many days has probably your father or your parents gone from their house to the field without knowing that rain is going to come, to open the pump set, to wait there, to close it and come back to put one person there? Happens, right? How many times you have actually not known how much of actual fertilizer I need to put for the field? Has happened, right? Because of the soil richness. If I had a sensor to measure the soil richness, if I had a sensor to tell me the weather, and then from home control the pump set, you can save. It means money is saved. So for your father or your parents or whoever it is, they don't have to go from their house to their field. They don't have to actually go and turn on and wait there. It can be all automated. So automation gets an example here, right? Similarly in healthcare, diabetic patients, they need to measure the sugar levels continuously. Today there are equipments where you can use to actually take blood samples and it gets automatically uploaded. You don't have to go to a doctor. Today it is possible, right? So in industry, for example, you know General Electric, GE? GE is a company which is now focusing completely on creating a platform only for improving the industrial internet or the industrial IoT. There was an industrial revolution long time back. If you guys have studied in your school, right? I assume you still remember. The similar industrial revolution for the industry is coming through industrial IoT. So retail, healthcare, and so on and so forth are all actually booming. So let us see examples of what is coming online. Right? So if you look at the next slide, you will see that there are more and more objects that are getting connected. So if you see, there are security devices, asset tracking, access control, traffic lights, telecom infrastructure, noise, air conditioner, vibration, right? Digital signage. You know what is digital signage? Digital signage is that if you have been to airports or if you have been to any public spaces, it's a digital billboard kind of thing, no? It's an advertisement. There are now digital signage. If you go and wave, it will know who you are. And it will play ads and play stuff that are relevant to you actually. Right? It will not know probably you as you, but it will understand that this person with this kind of a build probably is this age group. So this is the right ad to play, for example. What does it do? It simplifies choices. If you go to the supermarket, actually we were doing a project with a big telecom operator in the US, and they actually classified different kind of shoppers. So many of you go into a supermarket, many of you just go, and there are many, I'm sure, married people here. If they don't buy milk through a milkman, night they have to buy something and go home. They cannot, they are very focused. They will go into the shop, they will not buy anything else. Their only aim is to pick whatever Home Minister has said, and they will pick and go actually, right? So in this case, what they do is, they are called grab and go shoppers. They spend only 2 minutes or 3 minutes inside the shop. Even the billing process they want to finish fast. They are, and there is, like my son calls in our family, there are a lot of ladies. My son terms them as shopping monsters. That means they cannot get rid of shopping. Usually it is the fairer sex, the ladies. So they spend more time. They see more things. They want to know more about the product which they are buying. So today there are shops out there, and it's called proximity commerce. What is it called? Proximity commerce. Proximity commerce means how close I am to a particular. So in a mall, there are so many shops, correct? So in a mall, what now is possible is, they know due to Wi-Fi. So the minute you go into a mall, they give you free Wi-Fi. And you also think it is some great thing, right? And you immediately say, yes, let me use it, right? And the minute you select it, it is called campus networking. It can even be done in your college. So think of a use case later with that. Okay? So what that building guy does is, he gives you free Wi-Fi. You know why? Because now he is able to measure you are close to which shop. So immediately he will start sending you are very close to this particular thing, why don't you go there, you will get these things here. You understand? So next thing what he does is, no, he is not even doing through a mobile app. You don't have to download a mobile app. Facebook Messenger is enough. So immediately you will get a message, like, I am your friendly bot, you are nearby here, why don't you please go to the shop. The minute you enter the shop is enabled using certain specific features. So men's aisle will be there will be a women's aisle, there will be a kids aisle and all that. No? Where you go and buy for men, women, kids, toys and all that. So today there are cases where you go, you select a product, you can actually show your mobile phone as a camera, you can show it to the product, and the camera actually will go and, the mobile app will actually go and get a video about that product. And it will play you the video. So what happens, usually, before and after when you go to a shop, you take something, you will say, let me not buy this, I will ask my friends later, I will talk to some people and I will. No, you don't have to do anything. Everything is there. What is he trying to do? He is making sure you don't get out of the shop without buying. Right? But he has now automated the experience for the user where I go in, I don't have to ask anybody. Many of us feel hesitant, like many of you don't want to ask a question or answer, no? Hesitant. But I'm sure that you want to ask, it's just that I don't know whether I'm asking the right question. So similarly, when you are in a shop, you don't know whether what to ask, who to ask, no? So in this case, what is happening is a connected environment allows you to actually walk in the shop to know who you are, to be able to actually identify you, to be able to guide you. Then when you take a product, to also be able to actually ask somebody on whether this product is what I want or not. Now all this is possible because everything has started having an address, everything is connected, and the data about all those things are there in the web or with the provider. So Google created a very interesting application with Audi. Of course, this is not for all of us, but it's for those who have Audi and who have a Google Nest at home. How many of you know what is Google Nest? Google Nest. Anybody? Nobody? How many of you have heard about Google Home? Good. Okay. At last, somebody from the middle. Tell me what is Google Home. Yeah, I think it's a device?
No, it's a digital assistant.
Very good. Excellent. What is a digital assistant? Now you see, this is real value. These examples of real value, because here you have a sensor which he calls as a digital assistant. What does it do?
It schedules your work.
It schedules your work. So it's really your assistant, right? What else? Similar to Google Assistant, there is one more. You know?
Alexa.
Very good. Amazon Alexa. How many of you know Amazon Alexa? No? Ah, good. I have my own experience.
Going through Amazon, I have a personal experience with Alexa. I thought it would be very much personal assistant, but it was primarily trying to do what is based upon the key things. So if I want to play music on something like that, it will do that. If I throw some other question which is like you have to think, it does not reply answer having a yeah. So most of my questions are being like, sorry, I don't have an answer. So if you have a routine jobs like that, it is very good.
But what happens with these kind of digital virtual assistants is that you have to build skills. So every assistant has got skill. So what he is telling is, when I ask something about a particular thing to that assistant, it didn't answer. It didn't answer because it did not have the skill to answer. Who builds skills? Developers build skills. To build those skills, you need to know certain languages in which you can build those skills. Java or whatever languages you are learning. But there is a method to the madness. Okay? So there is always a method to the madness. So if you actually are able to take a skill and build a skill for Google Assistant, Google Home, or for that matter Alexa, it will do the work for you, right? So tomorrow you will see that there will be more and more skills that are being built. So if I do 1-800 and get me a roast, there are assistants to go get a roast, deliver at your homestead. So you don't have to do anything about it. So these are different kinds of assistants that are coming and they are delivering different kind of value. So today I have an Amazon Alexa at home. The danger with such devices is it's always listening to what is happening, and it is sending to somebody. Yes. Yeah, it doesn't know, but what it is doing is whatever you are talking in your home, it is actually sending back to somebody. Recording. It is like an assistant. See, that's why I'm telling you. Guys, that's why I'm telling you that it is only your imagination that will stop you. So you can have this particular thing. There is a company in Australia which built a device which actually their rugby is very famous, just like cricket. So every time there is a home run, that will light up and it will play an advert. And the guy who did it, it's a company called Bus. They get, for every advert, they get about $1 to $2. So the more the goals are scored, the more money to that particular company. But why this is all possible? That is very important to understand. It is all possible because those objects are now addressable. We should not miss that point at all. We should come back always to the point that Alexa or Google or Siri or virtual assistant or whatever you call it, all these are now addressable. You can talk to them. So the complexity of the languages that you need to learn, the concepts that you need to learn. If it is a smart agriculture, it is nothing big. You have sensors which keep sending data. Those sensors might not require information to go back. So there is always, when you talk to an object, there are two important things you need to keep in mind. One is the uplink and the other is the downlink. So in this case, there is something called CQRS. Have you heard of what is CQRS? Anybody? I will not tell you. You can go Google and find out. Okay, what is CQRS? So there is something called uplink and there is something called downlink. Why both are not together? Any idea? Why uplink and downlink with an object are not in the same path? How many of you know how a telephone works? How many of you know how this mobile phone rings? You know? No? Sorry? Full duplex. What do you think?
Sending or receiving data.
What? Yes, sending or receiving on the same channel?
Yeah. You are sending on the
same channel. See, the point is, when I tell you how a phone works, just so that you guys know, because this is important, for you guys to at least be realistic. The phone works in a very simple manner. When you dial a number, usually what happens, you dial, sorry? It connects where? It connects to base station. Okay, forget this one. Let's take your normal old phone, no, which you dial. How does it work? How does it know how to connect to the telephone exchange? Yeah, but how does it know? What is the concept of a dial tone? What is a dial tone?
What is the channel to communicate to the exchange?
You are not coming. Okay, in a telephone call, is the signaling channel and the media channel the same? Why? Why? How many of you know SS7 signal? Nobody? Okay. A phone works in a very simple manner. Think of it like a closed circuit, open circuit. So when you dial a number, as you said, it goes to the exchange. It knows because of the prefix. So usually your local number is different, that's why you need a STD code. Because it should go to a different addressing scheme. Clear? Then it will first know that if I put 044, it needs to go to Madras. If I put 080, it needs to go to Bangalore. So there is a trunk. All this signaling will finally go, and when there your phone is ringing, that means it is closed circuit. If it is busy, it is open circuit. Very simple. Right? So think of it like that. So in the case what will happen, your signaling channel, once it is established, and somebody says, okay, that guy also is ringing, it is also ringing here, the first step is to get the dial tone, which means I am able to connect. But this whole scheme is so that your signaling channel is independent and gets away from your actual media path. Because the codecs, the protocols required are different. I am giving this example because in IoT also similarly, codecs, security, protocols are different depending upon the network and depending upon the device. In banking, if I keep a sensor, do you think it will have the same security as a sensor in agriculture? No. Definitely, because the regulations are different, the codecs are different, which is why uplink and downlink are usually different. Clear? So that when you do uplink, more and more sensors will only do uplink. They will not do a downlink at all. Will you be okay if somebody actually opens your door, house door? That's a downlink actually. That's a command which is coming, right? So Google, what it does is, coming back to Google, Google Nest is a thermostat. It adjusts the temperature in your room. So what these guys did is, they connected an Audi car with Google, with the Google Nest at home. So the minute you leave your workplace, the building will tell to the car that so-and-so is coming. So the car starts the ambient temperature automatically in the car. And the minute you enter the car has an OBD, an onboard device, navigation system. In that, there is an infotainment system actually, it's called IVI. In-vehicle infotainment. So what it does is on the OBD, you can actually say destination home. The minute you say destination home, you can use Cortana. You know, like Amazon Alexa, like so there is also Cortana, which is from Microsoft. So you can actually say in people who have a Ford car uses Ford Sync. Very similarly, it's based on Cortana and others. And this is artificial intelligence. Okay. So what Cortana does is, or whatever is that OBD device, you immediately say home. So what it does is, it immediately talks to Nest and says, Swami is coming home. And Swami likes the temperature to be at 22 degrees when he reaches home. So it will reset the thermostat to 22 degrees. This is today. I'm not talking about some fiction. This is today. Google is doing this today. And what it has done, it has actually connected 2 or 3 services together to create this kind of experience. So sensors came online, they got address, now they are able to send information, they are able to also accept commands, and this sparks an entirely new revolution in terms of what applications you can build. Got it? So there are specializations in the area of devices, how to create a device. The easiest way to create a sensor, anybody? If I tell you that tomorrow I need a sensor which actually gives me the weather, how will you build it? Anybody? You can do it in a day. Anybody? No? How many of you know what is Raspberry Pi? 1, 2, 3, 4. What does it do?
It's a handheld computing device based on 1 GHz processor, 1 GB RAM.
Processors can be different, but what does it do?
It's a small computational unit.
Exactly. So how small can it get?
It's very smaller than an ATM card. No, ATM card. Lesser than that. It's Raspberry Pi 0 is very simple.
Very good. What else? Apart from Raspberry, something else is there?
We can interface a lot of sensors.
Yes, you can interface. What else?
It has general purpose input output unit.
No, other than Raspberry Pi.
Yeah, we have Android, XE4 and many other.
Arduino?
Arduino.
So all these are small. Do you know cost?
Recent Raspberry Pi W version is 900 rupees.
900 rupees. In 900 rupees, you can create actually a small computer. It is. You can add. It gets costlier as you add more sensors, as you said. But today, I can have a small sensor custom built in my home to do simple things like actually having a different electricity meter count, for example. So there are protocols like, in that case, what happens, metering and all, there are different protocols, SCADA and other things are there. So in case of basically low power WAN, so there is something called LP WAN. So low power WAN, there is something called LoRa network. Go read, I will not explain all that. You can go look at it by yourself. There is ZigBee, there is Sigfox. You know, there are different other network schemes that are out there, which actually will be very interesting if you go and take a look. This is at the connectivity side. You understand? This is at the device side and the connectivity side. So there are protocols like CoAP, there are protocols like MQTT, there are different other protocols that are coming online. But these are typically related to devices and connectivity. Right? So in this sense, you can actually do a lot of research, you can do a lot of interesting work around this space. The industry is really opening up in this space. So the innovation is starting here. So whatever Suresh was mentioning, there are many other companies like that which are specializing in what kind of control points they create. Why it's a control point? Because that is closest to the customer. Isn't it? So this is one. Next, once you connect, what is next? So let's say you have devices, you have connectivity, what is next? What is next? To buy a AC, what do you do first? Correct, after that. What are you worried about? What will you do first? You buy a fan is fixed, what do you do first? You want to know how to manage that device. That is the first step. Right? And you want to do it in a secure manner. So you need to understand what is the security principles around that device, what is the possibility of how to manage that particular device. This is the first step. And it communicates and all comes later. If you put a switch and it busts, will you actually be happy? You will not, right? So you need to first understand what is the security principles that wrap around that particular device after you install whatever, right? But what is very important is to understand what are the fundamental principles of managing the close, managing the no. You're missing the point. Your object has now got a address. Because it has address, it has become an identity. You have to move away from thinking that it is an object to actually start thinking that it is an identity. Why you know it is important? Why is it important? You think that I should address it as an identity? It's a cultural shift. It's got nothing to do with technology. It's culture. To differentiate things. Sorry. Okay, fine. Next. What else?
An object may not have an identity, but identity will have an address.
Without confusing, you should say.
An object may not have an identity or an address, but an identity will have a...
No, first he established it as an identity. What else? Want to say something, guys? Why is identity important? I'll give you an example of what we do. I was talking to colleagues yesterday and I was mentioning the same thing. If I need to book a meeting room in my office, or here if you have to book a meeting room, what do you do? What? Huh? You get permission. Okay. Then. Okay. Correct. And you put a meeting room name, everything. You schedule it. Very good. So think of a situation. How many of you use mail clients? Email clients? You use? Anybody uses? Everybody uses a mail client, Gmail or whatever it is. Right? So have you ever used an Outlook email client? Anybody? No? Yes, both of you. Okay, in that, the minute you put a name and you do a Control K, it will search from your contact list and bring them. Because the person went off into your contact list. Think the meeting room to be in your contact list. That is the power of becoming an identity. You understand? Because you think of it as another addressable person or entity which actually suddenly starts coming. So for example, this room, what is this room's name? X, some X, right? So if you take that X and if you start searching for X and say, I want to actually book a room. So today in my office, for example, the way we book a room is basically I go to an Outlook client, I just say IWF hyphen and I do Control K. Once I do Control K, it will show me all the IWFs with the green or with the red or with the orange kind of symbol. Green means it's available. This is possible because we started treating the room as an identity. It came online, it started publishing its presence. Because it started publishing its presence, I knew what I can do with it. Now, because it is no more an object but an identity, I do it very similar to scheduling a meeting with my friends, with my colleagues. So this is where things start becoming a little bit different, where everyone and everything will be connected and everything will be understood. That is not there without a meaning in that slide. When I say everything will be understood, it means that you can now start relating to these kind of objects. For example, so let's move quickly now. So that's what is millions of devices, and the first step, as I said, is connectivity. After connectivity, somebody said data. So data, right? So data is going to start coming in. So what will you do with the data? Process. Store. Okay. Process, store. Then. Process, store. Then. Search. Okay. Decision. Come to them. Process, storage. Then. What did you say? Okay. So basically what happens is, in this space, so first we saw connectivity. In connectivity, what is important to understand? Protocols and security. Protocols, what are important? 1M2M, CoAP, ZigBee, Sigfox, LoRa, MQTT. So these are the kind of things that you should learn if you want to work in that space of connectivity. Right? And security schemes, codecs, how to actually manage codecs and so on. So the minute you move up, then you are left messaging, you are left connectivity, you are left network bandwidth, you are left frames and everything. You are moving up the ladder in terms of the next layer. The next layer is data. So data, what did you say? The problems are, think of the problems. You are not, see the way you have to think is what are the problems that I can or I should be solving at that particular layer. Not necessarily to think about, what is the technology itself. You come to the technology. So you said processing, storage, what else was said? Storage was also said here. Anything else? Cleaning of data. How many of you think that data will be useful? Nobody knows it. So quality of data is very important. So you should know how to get to a good quality of data. How do you get to that? By actually adapting processes that are related to big data, Hadoop kind of technologies, being able to create a data lake, being able to get the data, being able to compress the data, being able to store the data. It's typically called data pipelines. Exactly. You need to pre-process, you need to mediate, you need to also actually post-process and store it somewhere. But there's no analytics step. It's only data. But it's only about handling data. And why handling of data is a challenge? It's not because of... So when data comes, there are 2-3 challenges. One is volume, second is velocity. The speed with which the data is coming. And then the volume of data. Right? These are the 2 big issues. But when you get these data and stuff like that, you put traditional practices like data mediation, data pipelines, and being able to store those data. But in this case, what is happening is each device or each category of devices. So in this building, let's say take your campus. Remember, you need to come back with some projects. So there are many sensors that you will put. They will all be with gateway. The data that they are going to be publishing are different containers of data. The different containers of data, you need to be able to handle it independent of the other containers. Otherwise, they will get mixed up. So data isolation is important. So data storage compression is important. So in this, what you need to learn, you need to actually do, there's a lot of research happening on compression algorithms in terms of how to store this data, how to compute this data, how to actually maintain this data over a period of time. But this is about data handling, data pipelines and data handling. Traditional technologies apply, Hadoop and other related ecosystems. But then what after that? So we're talking about zettabytes of data and all that. After you get data, next is what? What will you do with the data? Sorry? Okay, yeah, decision making. The data can be used for decision making. Analyzing the data. Okay. Why should I analyze the data? Why? Why will you do it? Why should I do it? If I open this door, why will I open this door? Why will I analyze the data? Simplify matter. See, these are all things which will not take you to the right thing. Why will you do it?
You get a better solution.
Problem is like the solution. What is the problem?
Only if you have the problem, you will analyze it.
But then what are you doing with the data? Read that. Show me the money. It's in IoT. What is the next word? Applying the data to a particular problem is an application. Without knowing the application, I cannot actually do anything. Only the application will determine your decision-making algorithms. Only the application will determine the pattern recognition. The pattern recognition will not drive the application. See, the problem is we all think bottom-up. Because we start from technology and we try to think technology and bore our way to the top. That is not the way to think. If you want to actually create a solution, as you said, a problem has to exist. To actually attack that particular problem is meaning you are applying something to reach a particular goal. So this is where the money is. The highest amount of money is in application. So if you see that value, that market size, if people have good eyesight from the back, they will see that application. Second one, I'm sorry for the, I don't know why it's coming with this. The second one is called IoT applications. IoT applications analytics. How much is the market size? 60 billion. That is the market size. Got it? So if you want to make a lot of money, focus here. Right? So this is the place where there is a lot of academic institutions, there is a lot of scientific bodies which are actually doing cutting edge work, including companies which are actually doing this. So in the maturity, if you see, as I said, in retail is the highest maturity, right? So in the retail, if you see, you've got nearly 45% of the focus being on retail. Next is industrial IoT. The third is fleet management, and then similarly you have connected home and so on and so forth. This gives you a very good idea of where IoT is being applied. And when you apply certain principles to a problem, it's an application. And the application is where the money is. So we saw data, we saw connectivity, we saw data, now data is becoming information. Data becomes information through application. Clear? So now let us talk about application. So what do you think are the technologies you should know to build applications in IoT? Very quickly, anybody? What technology should you use? Programming technologies, platforms programming. What do you think you should use to actually build IoT applications? How many of you know JavaScript? Nobody. Nobody knows JavaScript. Python? Python? Okay, good. Python? Yes. Anybody else? Why do you think Python is a good language to build IoT applications?
It's very simple and libraries support IoT applications like Scikit and other applications.
Very good. Why Scikit is important?
It actually helps in data analytics.
Very good.
Regression, data compression, support automation.
Algorithms mainly.
And Python also have ability to access the hardware GPUs. You can access.
In C, C++, you can access GPU, no?
Yes, but
yes or no?
As easy as possible.
Python is easier. Do you agree? Yes. What else? That's it? Okay. Anybody else? Why Python is interesting for you? Can you say a few words? Syntax is not a problem in Python. Okay. What else?
Like you said, libraries are much
mature. Okay, it's easier. So it's more approachable as a language. Okay. Which language do you use for it? That's all. You should say apart from Python. How many of you do programming here? How many of you really do programming? I saw only two people doing. They say who does programming. Who else does programming? No? Nobody? The main technologies that you should know when you do IoT related applications, Python is the most approachable language. And why it is the most approachable language? Because it has programming nativity that can run also on a Raspberry Pi. It's the most simplest way. Even Java can run. Okay, but Python is very easy to run on a Raspberry Pi, for example. Apart from Python, Java is very interesting on the server side. Apart from Java, JavaScript is big. Very big, JavaScript. Okay. So if you learn languages like Python, Java, JavaScript. JavaScript is very interesting because it can also be a front-end development. Okay. But there are a lot of libraries that allow you to build a lot of tools lot of tools that allow you to build, let us say, these kind of applications. So some of them which you can go and see on your own is like Node-RED. I don't know if you've heard of it. Node-RED is one very interesting cloud-based free tool that you can go and see. But these are the ways to build applications. So where can applications run? Where do you think IoT applications will run? I said 3 parts, if you remember. Where can IoT applications can run? Number 1, healthcare. No, healthcare is a domain. Where will the application run? IoT applications can run, number 1, on the device itself. Correct? It can run on the device itself. Second, it can run on the where can it run? If you build an IoT application, first it can run within the device. You can build a mobile app, or you can build, let us say, something that runs on the Raspberry Pi, or runs on the sensor itself. Second, where can it run? Cloud. No, before cloud there is something else. Who is database? Okay. Data gets stored there, right? But where can it run? Application is running. End user application, not just data. End user application means small application that if I press will switch on the light or something like that. Application. Where can it run? First one is called the field. It can run on the sensor. I used this word before. It can run on the field. Second, it can run on gateways, which are aggregates of sensors. I will give you an example. Street light. In one street, you will have many street lights, right? All of them cannot start talking directly. They will all first talk to a gateway. That gateway will manage the street lights. That gateway's address only is known to the cloud-based application. Understand? So there is something called field on device, there is something called field gateway, then the third is your backend application, can run in the cloud, can run on premise, whatever. For each one of this, the technologies, the challenges are different. And it entirely depends upon the use case. For healthcare, the sensors are different, the protocols through which they send data are different, the way the processing is done is different, the way actually you maintain the data for a period of time. Do you think that healthcare and street light data will be maintained for the same time? No, right? Street light is more ephemeral, which means it will be there only for some time. But healthcare data, you need it forever, for example. So the data technologies that you need to apply are different. But unless you understand this connectivity, security, data, information, kind of action, kind of whole thing, you will not understand what technologies to use where. So anytime you think of IoT problem, you should first think of connectivity. Within connectivity, you need to think about protocols, about security. Next is what you need to think? Data. What is the kind of data? How to handle data? How to actually process the data? Third is how to take data, make it as information and take action. Information action will be within the IoT application. Clear? Okay. So let's talk about a little bit of quickly. I think we're out of time already. So quickly, brilliant. So if you look at manufacturing, there are some examples. Predictive maintenance, asset management, AR, augmented reality and remote guidance. There are different examples that are coming up in different industries. Smart cities is about water. So right now we are actually beginning to do in an apartment, for example, a person with 6 people in a family and a person with 2 members in a family pay the same amount for water if you live in an apartment. But if you start having sensors and if you are able to start measuring, then actually you are able to say that this guy living in a 2-bedroom apartment with 6 people is consuming more than me living in a 3-bedroom apartment with 2 people. Clear? So these are the kind of things that are being waste management. Waste management with bins which are, yesterday when I was coming I saw some bins which are all stacked up. But these bins will start telling that I am full or not, I have to be taken out or not. You understand? More than anybody knowing, the bin will start calling you. So the bin will be attached to you. The guy who is actually taking and picking up your garbage will actually know what to do with it. So these kind of things are coming up. Healthcare, elderly monitoring. India is still a young, and now recently I think we changed the definition of youth. Youth means till 50 is youth now. So they changed the entire definition of youth. So So anyway, the point is that once you go into elderly monitoring, it becomes very interesting. Japan, for example, is a elderly, predominantly elderly. They are about 67. So a very big population in Japan is elderly. So their biggest problem is to have elderly monitoring at home. Because they all need to work from home. Next generation cannot be at home. So how do you monitor, your parents or your elderly? That's a very big challenge. And that is coming in India. In another 10-15 years, because we change our definition of what is youth and other things, it is coming in India. So there will be a very big opportunity to actually have elderly monitoring. Already if you see, Pyramid Natarajan has started this this home delivery service. Why do you think he started? He started it because he is now getting a clientele who are not cooking at home, who are not able to cook at home. So he is delivering. Next thing he will start delivering is different carriers with sensors. It will tell how much this fellow ate last night. So next time when he gives the sambar, he will only give that much extra. He will not pour more. This is called operational efficiency. In colleges, if you see in your institution also, they will talk about operational efficiency. Operational efficiency is not about doing things better. It is about restricting waste. If you curtail waste itself, efficiency increases actually. Right? So these are things that are coming up. So similarly in agriculture, similarly in healthcare, these are coming up. And buildings. This is where I think it becomes very interesting in your college. So there's so much campus, so much building. You can build fantastic applications using all this. So transportation, retail, energy, that's more. So there are some very interesting applications here. I'm not going to go through all of them. If you see within buildings, the office can dynamically schedule rooms that I was mentioning. So next, you are guided through the attraction. So today, for example, after the chief guest walked, I also walked. I didn't know the session was here. Now, if there was a sensor which already guided me, it would have told me, Dumbo, don't go out, your session is here. Right? I would have stayed back. What I'm trying to say is that personal organization and stuff like that becomes a very interesting area. You don't make a fool of yourself. Right? So it becomes very interesting from that perspective. You are guided, a smart shopping list. How many of you get shopping lists? I do. So there is an organic store that I buy from when I'm in Bangalore. And this lady, she's very nice. She keeps sending me this shopping list every day, telling me that, please order. What are you doing? Right? So I get reminders. Now, what we did for other customers, we made the shopping list dynamic. You can speak, and you can actually choose your shopping list today and say send it. So it becomes those kind of things. So all these are very interesting applications that are coming. These are buildings and venues. Next one. So hospital, for example, checking into hospital, getting appointments, meeting your doctor. All these are being automated. Not only in India. This kind of thing works in a country like Egypt. So it is not just a phenomenon of developed versus developing countries. It's a matter of convenience. It's a matter of automation. So if you keep rolling through where it is happening, airports, bus stations, you get directions, you get relevant content. So all these things are happening. How many of you know what are bots? Bots. You know what is a bot? Very good. Correct. Automated machines. What is a bot?
It's like a robot track. It automatically replaces our command.
What do you think of what should do? What should do?
Respond for our messages.
Respond for our messages. A bot is a piece of software code that exactly does what a human can do. That is all. So that is, when you are having free time, go take a look at something called as Turing's test. Turing, T-U-R-I-N-G. So everybody in computer science field should know who is Turing. So take a look at what is a Turing test. A Turing test actually decides on how much a bot can really do when compared to a particular human. So there were a lot of bots in the olden days. It was called web bots. So they would say, don't open this website, go crawl and get some information, don't open. They were called bots. But nowadays bots are intelligent agents, like your virtual agent that you are mentioning is a bot. Alexa is a bot. Right? So it is able to actually imitate what a human would do. For example, so there are use cases where comes and says, you are not in the right direction, take a right to actually go to where you want to go. So this is possible. So people, my son is a big fan of Iron Man. So for him, everything is like Jarvis. So people who know Jarvis is a what? For example, right? If you know your Iron Man. So there is automation and there is innovation and efficiency that is being delivered in the industries. I will not go through this, you can probably look at it later. But there are very different things like getting to this place from the city is a nightmare. So if you had traffic lights which can actually tell you, if you can have a smart city which actually tells you the best way to go to Avadi is not through this shortcut but go through the ring road, you would rather take the ring road. Today you do it through maps. But the idea is if the sensors start sending it to an application, the application starts telling you that no, don't go this way. So there was this guy, two guys in IBM who actually had to wake up every day and they had to catch a ferry, and using that ferry they had to get to a place, take their car and then go to their office. And every day morning it was a nightmare to get up correctly and guess when the ferry will come. So what these guys did is they attached themselves to the city corporation through sensors. They agreed and they built a small application using a tool which they devised called Note Ready. It's free in the cloud, you can go and take a look at it. So, no, this is a wiring tool. They built an application builder, drag and drop, which, for example, companies like HP and others, we build our own tools. But why I'm telling you is it's available for you. So you go take a look. So they built this because they didn't know when the ferry was coming. So they built a tool which actually takes the ferry time, looks at the weather, looks at the traffic pattern, and tells them what is the direction to take. And every day morning it will be readily available. Like the presumed coffee that we hope to get every day in the morning when we wake up. Something like that. Right? So these are the kind of innovations that are happening. But again, as you see, necessity is the mother of invention. It's not the other way around. So just with IoT you can't do anything unless you have the right use case. And you think from the use case. So there are a lot of things that are happening in wide areas as well. Let's move on. So there is connected cars and there is a city that knows about its citizens, threat information, all that kind of stuff. So I will leave you with the last slide. Next slide. Let's move on. Next slide. So let's move on. So usually we come to the last end of this and thank you for bearing with me. The last thing that you need to understand is sometimes IoT is like blind man catching an elephant. But always use the fact that the application, the end goal is what has to drive why you need IoT. Right? And if you touch this blind elephant, it will tell you, think about things and security. Think about connectivity. Think about what is the edge infrastructure. I said in the field and outside. Think about what is the apps, how conversational it should be. Whether you need only an uplink or whether you need downlink, whether you need, as madam here said, duplex information, whether you need bidirectional stuff. What are the digital ecosystems? What is the edge infrastructure? In the top 10 or whatever trends in 2018, Gartner publishes a list. This is freely available. If you go and look at it, there is intelligent, a concept called intelligent apps and analytics, intelligent things. There is AI foundations. If you see digital, there is a digital twin, cloud to the edge, conversational platform, immersive experience. You can go look it up at Gartner. I will not tell you what it is, go do some reading. But the biggest thing in the industrial IoT is the concept of a digital twin. Digital twin means taking a physical object and having a digital representation of it in the digital world. And anything that happens in, for example, if you are doing a machine, if you're in a lathe, or if you're doing some machine this one, then the whole thing, as the machine works, it can be modeled through its digital twin. So there are today tools that model objects as digital twins. So you can go to actually a place where you can say, I want to see the digital twin of, let us say, the car. So it will show you a digital twin of the car. As the car moves, this one, it will keep sending data. And you can actually see all of that through its digital twin. So this is a very interesting concept that's coming up. So take a look at this. IoT, there's no stigma attached to it. IoT is as impressive or as relevant only as your application. And when you start with your application, look at the industry. From the industry, look at what connectivity I need, what data I need, what information I need, what action do I need. And based on that, decide what technologies are required. Each one comes with its complexity, but each one is well defined as well. It's just a matter of looking. in the right place. Okay? So with this, I will stop my session, but before I go, I want at least 5 applications from you guys which you think are interesting according to you that can be built for your campus. And what? At least 5.
Attendance purpose for students.
You want to make sure it will be. Okay. So what will you have as a sensor?
Classes that are going right. So like case recognition or
Remember, device, connectivity, data, information, application.
so in class we should have some sensors that it can be
How will you build that sensor?
at your office department.
How will you build that sensor?
So like says like a face recognition or
Face recognition.
hand recognition.
Very costly. Business case will not play. Nobody will approve it.
Sir, communication.
Come. Biometric. Good. Yeah. Possible. So that will be basically the way you acquire data. So somehow you will acquire data. Then, this is really IoT. This is biometrics. Where is the IoT in this?
You can use it by sensor. We can send it to department.
What is that sensor doing? See, this sensor is a very fancy word. No? What is that sensor doing? How big is it?
It's taking data, sir. What
Where is it? Should I carry? Then where is it? It will be mounted on the wall. Okay, you don't know how to implement it. Okay. Next. If you cannot implement it, it is not possible to do it.
Digitalized ID cards for both faculties as well as students. Where,
for both faculty and students, huh?
Yeah. It will track both faculties as well as students. Actually, it will have more interaction between faculty and students. It will help because students will...
No. Remember, connectivity, device, data, information, action. That's all.
It will have GPS sensors interfaced in the ID card.
So it is actually behind your ID card?
It's behind.
Or it is in the ID card? Okay.
It will have GPS sensor. It will track down where the student is or the faculty is. And it will inform it to the others.
Who is others?
Everyone.
Everyone, huh?
Actually, for example, I'll just say, one second. If faculty is going to come to our class, we'll exactly come to know where is this position at.
So that from wherever you are, you can come back to the class.
Yes, exactly. That is what I mean. And it is same for the faculty. He or she will come to know where the student is, whether he's bunking the class and going out, or he's inside the class.
But okay, alright, fine. So basically, an intelligent ID system is something that will help, mainly for supervision. No value otherwise. Okay, mainly for supervision. Anybody else? This do you really require? Because I don't know. There is an ID swipe and you just show, you will know. No, right, fine, the concept is fine, but I don't think it's practical. What is practical? Come out of this bunking and all that. Come with some other application.
Present or not.
You have ideas? Please share. Just give 5 minutes.
If it is tracked down, his attendance will be automatically updated.
Let's come out of this attendance bunking stuff, okay? It's not very productive. Because bunking is beautiful, so leave it. We can get into a different zone. So forget bunking and other things. Any other? I'll give you an idea. You take it from there. Transportation. How much time do you spend in the bus coming here? Huh? Every day 2 hours? Every day 2 hours. You are in the campus for how many hours? So 20% you are spending in bus. Don't you feel that tracking back your buses, be able to understand when it will reach. It's important to actually make efficient use of your time. So you should think transportation, probably. One. What else? Food is good at your... food is good? No. Okay. So transportation is one which I think will be very interesting to help basically make better use of time, traffic and so on and so forth. Most of the schools today are implementing both, not colleges, I mean schools are implementing this both. One is to have intelligent ID cards, especially for the female child, which is very important actually. Especially when you stay back, you do projects and other things for safety. I think it is a very interesting and very important, not for bunking. Purpose is different. No bunking. Bunking will happen whether you have card or not. So you need to actually find a way to make intelligent use of this. Anybody else? Apart from transportation. Fine.
Now we are in the artificial there will be light and hand will be on, right? So when a person leaves the hall or any place, he has to turn it off immediately, just like you have mentioned.
What is the value?
The value is like power as well as...
What is the value? Save power means save money.
Yeah, it's money.
But there will be somebody, no, I'm sure. After we go out, somebody will say, go first switch off all the lights. Then somebody will continue to switch off all the lights.
I mentioned a thing called start go.
That fellow will never switch off later. Government offices. First in college we will say. Labs. You can do what? Okay, but the delivered value according to you is savings in power. What will happen to the job of the guy who is switching off the lights? His job will be there or it will go? No, it's an important thing. See, the problem that you people don't understand is at this age, the problem that you don't see at this age is the social effect of what you are doing. See, beyond technology is society. There is a society. You are affecting society. All that you are doing is affecting society. When you actually say something, like for example transportation, you are not affecting any social setup. You understand? The driver will still be there, the bus will still be there, you will still be there, you still have to commute, everything is still there. But what happens is the bus gets linked with the city system. You actually can go on, there's an API. APIs are very important. So there will be an API for you to integrate. You can get the bus information, the route information. You can actually do all that. But society is improved with no deterrent to an existing job. But whatever you are telling will affect the job. So automation will remove jobs. You're okay with it? You're okay with it? Good. Oh no. What I'm trying to say is beyond technology, there is a responsible solutions that we need to create, which is very important. But the idea is about automating, reducing power consumption. Forget about whether we are gaining money or not, but we are reducing waste and improving efficiency. Okay. Next. What else? 2. You got 2. 3 more. Yes. We are creating a solution. But now the problem was so clear, we didn't even have to tell what is the solution. Before he told the solution itself, we thought, yes, it is applicable. So these are the kind of things that actually make IoT click. And what we said is not really IoT. But the way actually this can be delivered is by having campus networking, by having actually surveillance-based systems actually connecting and then using that to send. And you can actually create a EPG. For example, a programming guide, to say that this lecture today is important. Not everything is important to be recorded. So this is a learning delivery system that you can build through IoT, which I think is very interesting. So we got, I think, one more. What about the healthcare in your, how do you do healthcare?
Ambulance services.
Ambulance services in there. Huh? What? Stress management for students. Why? What is IoT got to do with it? can sense your presence, based on the presence tell you what is the important books that you can refer, for example. Here there is automation and improvement of experience, user experience. So my suggestion to you guys is think about a practical problem that you can solve, that can deliver value to both you and your society around you. And if you can do it in such a way, then it will be fantastic. Especially the and fully with, because none of us really are tuned to that kind of mechanism, which is actually a learning delivery system that is coming through remote. If I miss a class, how will I learn about it? That stigma must go away. By having sensors, by having connecting all this, actually you can even track the progress of that day, whether he really went to the lecture or not. So I think those kind of applications will make a lot of sense. And with that, thank you very much for the opportunity.
My paper is on various implementation of ECG, future extension. It is a survey or a literature review paper. So, telling about an introduction, abnormal rhythm of a heart, which is caused by the problems of your heart electrical system. The electrical impulses may happen too fast or too slow. So, based on this fast or slow pulses, the rhythm that makes the abnormal. So, it creates a problem. So, based on that, it has been divided into two types. So, that is what we deal with. So, based on the rhythms, if it is too fast or too slow. So when the heart doesn't beat properly, so it can't pump the blood very efficiently. So that the lung, brain and all other organs which cannot work properly and maybe it can shut down at any time or it can be damaged, it can be blocked at any time. So in a recent survey, sudden cardiac death, so it's approximately about 3 lakh deaths. So in United States itself per year. In most of the cases, this research is called as ventricular arrhythmia. So including which is ventricular tachycardia beating or ventricular fibrillation. Fibrillation is another name which is called as ventricular tachycardia. So this based on the ECG rhythm, approximately about 75 to 88% sudden death in person due to the heart problems. So unless the treatment is within the second. So at any time, at any cost, maybe affects goes to the death. So this ventricular tachycardia is a fast rhythm. So fast rhythm means the heart will pump the blood with the jet speed when compared to the normal. So the normal speed is about 60 to 100 bytes per second. So if it is greater than 100, it goes to the ventricular tachycardia. So ventricular fibrillation is another rhythm which is disordered activity of the ventricles, causes an immediate cessation means it stops the blood. So that is it will be pumping the blood in a slow So further the pulse, sometimes it may be a flat easy means the signal goes to the neutral or zero. That is no pumping for a certain duration of time. So indicating no cardiac at the time the electrical signal it will be neutral or it will be zero. So this case called as a ventricular fibrillation. So for this implantable cardiovascular defibrillator has been considered as the best part for this protection. For the high-risk individuals, they are placing this ventricular defibrillator. So it is an electrocardiogram, it's mainly a periodic signal that reflects the activity of the heart. Sometimes you can monitor using a long-term ECG monitoring to detect any changes in the characteristics of the ECG. So there are 12 leads ECG, that is the 3 standard, which is limb lead as well as the augmented limb lead, and 6 periodical leads. So limb leads, such as in the case, it has 1, 2, 3 and then augmented limb lead, ABR and ABL and ABF. So these 3, and then 6 periodic leads is placed in the limbs. By extracting information from this interval, so the change in the amplitude as well as the waveform based on the standard case. So comparatively, we are comparing to the standard ECG signal, we are comparing to the Nature-Light or abnormal signal by comparing the 2 waveforms. So we can plot the different PQ August T waves. So PQ August T, so this is the ECG signal wave which is generated by the ECG monitoring output. So the VLS implementation is ECG, which is a future extraction. So we can enhance, we can improve the final output based on the VLSI. We can implement using the VLSI for the final accuracy. We can go to the next extent. So in the medical field, so normally VLSI is implemented in several other fields. So but in the case of medical field, it is coming up. So these are the literature surveys which have been noted down. So it's a paper in 2016, which is presented biooptimum DWT. So discrete wave technique, wave transform technique to remove the noises. So how to remove the noises in the PQ or the ECG waveform. So the noises are caused by the power line. So with 60 Hz. So baseline matter is nothing but so noise which is obtained by means of muscles or some other object which is connected to the ECG wave. So some external components, whatever connected, so it also creates some noise. So which is created by the noise, that is a baseline matter. So it is up to 0.5 Hz. So when studying the ECG detection. So high pass filter as well as the low pass filter, you all know. So it eliminates the high frequency. Whereas low pass filter eliminates the lower frequency signal. So used to remove the interference in the detector signals. By using this purpose, so the R to R, that is T to R is T, that R to R wave influence in the Q RS complex and the heartbeats are measured along with this technique. And other paper which is done in the Jan 2016. So in this ECG classification, it is coupled with 3 different chips. So we are placing a 3 different chips. The first chip which contains the body circuit, which is placed in the body that will high pass sigma delta modulator based biosignal position. So and another one, second one, which is on off being transmitted. The second is receives. And it is placed in the receiver end and has the receiver and the DSP, that is digital signal processing unit. And then the third chip is the classifier. So the classifier is differentiate to find the variation in the signals by placing the classifier, what kind of signals. So the discrete wave transforms will be adapted in the DSP unit based on the ECG features extraction in the classifier. So these 3 chips will identify and distinguish the different signals. So other paper in 2016. So this deals with the string implantable ECG system in a aerodynamic classification based on a state of art of 65 nanometer in a CMOS pulse. So it's a simple VLSI, they have not done in the VLSI CMOS pulse. The system appears the ECG signal, it will do these 3 things. Mainly what the signal which is obtained, it is filtered and it is amplified to a particular level. So while doing this amplification, the signal which is in the low level is amplified to a particular extent so that we can analyze and execute the certain waveform very clearly and digitalize it. So it will digitalize. So analog to the digital conversion is done at the time. So that which has been amplified to a variability amplifier, and the successive approximation register. Automatically it will store the data what is received and it is converted into a digital number. So these are several survey papers. So the motivation of ECG, ALMS direction, a normal heart rate between should be, as I already said, 60 to 100 beats per minute. So if it is varying in this case, if it is varying in this number, if it is below 60 or above 100, so it is critical something. So ALMS causes a disturbance either in the heart rate or in the regularity of the beat, or the site of sign, or the conduction to the heart. So the features were measured from the QRS complex. The QRS is the points or nodes PQRST. Like this, we are pointing the different nodes. So we are going to analyze that and measure the QRS nodes. The parameter is converted. The important thing is that we have to analyze this PQRS. So the major problem is in the automatic classification of the ECG beats or to considerable variation of the appearance of normal and abnormal ECG. So mainly we have to analyze which is a normal ECG signal from which how the abnormal signal varies, at what time it will be varying. So there are certain limitations while identifying the ECG absence detection. The main thing is the main noises. So noises in the case, so by doing a measurement, so it can be breathe due to our breathe or the lung functions or the vowel sound. This means some sound which creates or generates due to the breathe, and then the baseline matter. So due to the instrumentation which is connected around the instrument or ECG monitoring, and then electrode contact noise. So what are the noise which is connected in the limbs? So due to that noise, electrode contact, as well as electrical interference external to the subject or the record. So any external electrical interference. So due to that also the noise will be generated. And then high frequency noises. By generating the signal, so some certain high frequency which disturbs the ECG signal output. And then the motion artifacts. So motion artifacts means, so while analyzing or monitoring the output through the ECG output. So due to that motion itself, it will be irrelevant to the what we expect. So maybe in some case of delay or some changes. So due to the previous errors, it may create some motion artifacts. So then muscle contraction. So due to our heart muscles or the external muscles, body muscles, during that contraction also, if we are feeling very stressed, so at that time also the ECG signal will be not either, it will be not in a regular. So due to our stress also it will be. So noise generated by the electronic devices which is used in the signal processing circuit. So externally we are taking the output and then we are analyzing and then processing. So at the time also due to that processor, so the processor what we use, so if the processor is default, if it has a define, so it creates a noise. So we have to be we have to use the very proper and it should be a faultless circuit. So the circuit which is used for the analyzing, it should be a flawless. And then some instrumentation noise. So it is happens with the power supply fluctuations. So even though the power supply, it should not be in a fluctuation. So the voltage level or the frequency level, if it is varying at the time also, the noise will be happening. So indirectly the patient's records will be wrongly matched. Okay? So it happens due to the power supply fluctuations or any other reason such as electromagnetic interference, such as RF signal. So if we have used a mobile phone at the area, so while monitoring the records, these are all very weak noise, but it make a huge difference. So many methods are proposed to denoise and detect that. So our aim is to find 100% efficient, 100% output. So the patient should not be damaged at any place. So we are expecting a 100% error. So each method has several meanings as well as several inherits also. So the motivation of ECG arrhythmia is next. So inaccuracies in the input feature. So vectors of the classifiers are caused by the substantial overlapping of the frequency. As I said, P wave and Q are less complex than noise. The problem of the ECG deviation among the person, the same cardiological condition affects the performance of existing arrhythmia classifier. So many arrhythmias can indicate the serious cardiac dangers and need an immediate attention. So we should not set all the patients in the same way. We should not, because every person have their own records, own value. So this is how the calculating the heartbeat. So the R interval is a R node, it's a maximum amplitude. It should be 100 beats per second, the peak. So if it is greater than it is called as an arrhythmia. So P, Q, R, S and T wave. And then second question, the R to R interval we are calculating. So the heartbeat rate in beat per second can be calculated using this formula, 16 seconds and per minute only we are calculating, divided by R. So there is a heart rate. So what is our heart rate? You can also calculate using the R. So there are several abnormalities and their characteristic features. So we are going to classify. So these are all the essential first one. So normal sinus rhythm. So for normal person, normal human being should be 60 to 100. So the R interval should be 0.60 to 1. So 0.6 to 1 is normal human being, normal sinus rhythm. So if it varies, if it goes above 160 to 240, this arterial tachycardia. So the R interval goes to 0.25 to 0.5. Then tachycardia, it is a low heart rate. So if it goes less than 60, or heartbeat rate, if it goes less than 60, it is tachycardia. And arterial flutter means it will not stand for long. It will be going for a certain moment, for a short duration of time. So 240 to 360. At one certain case only it will be going for 240 to 360 and then it will come back to a normal mode. So that is a fluttering noise, arterial flutter. So arterial fibrillation, it will be goes on random. So there is no any proper PP or ST. It will be random, 60, 100, 240 and then 30 like that. So it's a very dangerous arterial fibrillation. And then ventricular tachycardia is 110 to 250. 110 to 250. Then ventricular fibrillation is because of ventricular muscle. So that is arterial and then ventricular. So it is greater than 250. So synthesize the ECG recording for one single heartbeat. So this is one single heartbeat waveform. So P, Q, R, S, T. So P node. So P to Q, that is P to the second one, P to R segment. So for the next consecutive segments, the time seconds as well as the segment intervals are noted down. So Q, R and S, that interval, Q, R and S interval is very most important. It goes to a maximum up to 100 only it should go. So below 100. So this is the action potential So from the arterial muscle, it goes to the AV node. So AV node, that red color, so red color AV node. So that electrical pulse has been transmitted to the AV node through the arterial muscles. So from the AV, it goes on to the common bundle. So common bundle of lines is common bundle. Through that, it reaches the pulse is being split to a bundle of lines. And then it is divided to the Purkinje fibers. So the fibers in the ventricular muscles, it has Purkinje fibers, it has distributed, and it is distributed to the ventricular muscles on the two spacious ventricular muscles. So this is how the electrical pulse has been transmitted from the sinus node to the ventricular muscles. So this is one part. So the reaching time for the ventricular muscles, it takes that 200 milliseconds. So what the maximum amplitude is reaching at the R node. So from 0 to 250, okay, 250 milliseconds. So that duration. So only we are getting the maximum value. So that R node. Okay. So the P and Q, it is in the maximum, little about 40 to 60, and then it goes to negative, and then to maximum P, and then it is lower. So this one should be repeatedly going. So and the second initial pulse will be generated from the sinus node. So this is a repeating process. It is successively continuing throughout 24 bars. So our purpose was to focus and design a fully integrated electrocardiogram, ECG signal processor, that is ESP, for the prediction of this ventricular arrhythmia using a unique set of ECG features and a neural network classifier. So the future extension for the reliability and the decrease in the complexity of the ECG classifiers. So we have to classify. So we are decreasing the structural complexity. An implantable cardiovertical defibrillator, that is ICD, is a battery-powered device which is placed under the skin, embedded in the collarbone, that monitors your heart rate throughout the entire. We will be monitoring throughout your regular activities. It uses battery to send the electrical signal to the heart. So that is being too slow or too fast. So as well as a pacemaker, it is reliable, and then it is similar to a pacemaker, but if it fails, if the pacemaker, one disadvantage is that is it will never give the voltage signal. But in this integrated cardiogram electrocardiogram, if the electrical signal is abnormal, or if it goes to less than 60, so this integrated electrocardiogram will give the pulse to the sinus node. So to make that normal. So it can also deliver an electrical shock to help to restore the normal point. So it can be restored to the normal point. So future implement of low power wireless transistor module to transmit the biomedical signal and employ a different filtering technique to monitor and to remove any type of noise. So as I listed out the various noises, so we have to apply for our filtering techniques to remove a certain kind of noises. So these are several performance parameters we are going to be analyzing. There is a specificity, accuracy. Yeah.
So what is the main objective here?
Yeah, actually we
are
existing
12 leads ECG.
Yeah. No, we are actually integrating a cardiogram we are going to design. So in that, it is the ventricular arrhythmia. In that case, we are going to analyze that regular heart rate. If it is abnormal, so it will be giving a shock or a pulse to the sinus node at any point of time. In case of any abnormality, and it also be It's non-invasive. Yeah, it's.
Because already existing is actually not needs of your country.
Yeah, but we have to face how kind it's a paperwork only. You are not in a regular way. But we have done some literature survey works for post papers.
I have few questions.
Yeah. Yes.
So you have mentioned the WT or DWT.
Yes.
Literature. What is it?
Ma'am, it's analyzing both the frequency as well as
What is DWT?
discrete wave technique. Discrete in which it will analyze both discrete wave. Yes. Yeah. Discrete wave. That is transformation. It will be analyzing both frequency as well as time division.
So the survey can be given in terms of tabular form, instead of stories.
Okay.
Okay? So author, what is the methodology adopting, what is the merits and demerits, what is the accuracy, etc. You can
Sure.
You have mentioned the structural complexity of the ECG classifier.
Yeah.
So how will you measure the structural complexity?
In this base, we are going to compare only from the normal ECG signal to the abnormal one. But complexity in the case, what we are going to reduce by using our ECG, we are going to reduce in size as well as the power level. By solely we are going for a VLSI implementation.
What are the parameters to be used?
Say VLSI.
Structural complexity.
Parameters, power level we are going to reduce, and then a few noise also we are going to reduce. Power as well as noise reduction.
How will you enhance the reliability of structural complexity? In your proposed work you have given that.
Yeah. Enhancing we have to do some.
What is reliability?
Reliability is what I have planned is which is reliable, which is easily viewable to the viewers. That is, the output should be reliable, means it's efficient. How efficient the output is being.
Go to the first introduction slide. How to interact both RFID and IoT? How the RFID tag can be used in IoT? In what way? In what way you are replacing the RFID tag with the IoT? It is one of the important components. RFID is one of the important components of IoT. How do you make an interface, or how the IoT will be interacted with the RFID?
See, as he said, there is an identification number will be there, RFID tag. Using that as a key ID, you want to take necessary actions or decisions based on the.
RFID as a key ID only.
If you implement, you can easily tell the answer.
Implement that?
Only idea. Post idea is.
Because of large potential of this domain, IoT is used
used as industries and some Microsoft techniques and their HPs. So this is used. இது வந்து அப்புறம் வந்து ஹாஸ்பிட்டல்ஸில் அங்கே வச்சுருக்கோம். ஹாஸ்பிட்டல்ஸ் ஒரு சர்வர் சென்டர் மாதிரி ப்ரொவைட் பண்ணியிருக்கோம். அங்கேருந்து பேஷண்ட்ஸ்க்கு எப்படி அப்படி இங்கே ஏதாச்சும் பேஷண்ட்க்கு ஏதாச்சும் ஆச்சுன்னா ஹாஸ்பிட்டல் சர்வர் மூலமாக தெரிஞ்சுக்கலாம் சுற்றி என்ன நடக்குது அப்படின்னு. வில்லேஜஸில் பார்த்தீங்கன்னா வில்லேஜஸில் இப்போ டாக்டர்ஸ் இல்லைன்னா அந்த மெசேஜ் வந்து அர்பன் சென்டர்ஸில் இருக்குது, நியர்பை அர்பன் சென்டர்ஸ்க்கு போயிடும். ஸோ அதனால் அங்கே இருக்கிற டாக்டர்ஸை கான்டாக்ட் பண்ணி நம்ம தெரிஞ்சுக்கலாம் இங்கே என்ன நடக்குது. அண்டு காமன் டிசீஸை கூட இது மூலமாக ட்ரீட்மெண்ட் பண்ணி கரெக்டாக கண்டுபிடிச்சிடலாம். காமன் ஃப்ளூ, கோல்ட் அதெல்லாம் கரெக்டாக இதை ரிஸ்பேண்டில் யூஸ் பண்ணிக்கலாம். ரிஸ்பேண்ட் அப்ளிகேஷன்லேயே வச்சுக்கலாம். நம்ம கையில் கட்டிட்டு நமக்கு ஏதாச்சும் ஆச்சுன்னா சம் ஏரியாஸில் இருக்கும்போது அது மூலமாக கூட பண்ணிக்கலாம். இந்த மூலமாக ஒரு தடவை நம்ம சர்வர் மூலமாக ஏதாச்சும் ஆச்சுன்னா அதோட பேஷண்ட்டோட ஹிஸ்ட்ரிஸ் டீட்டெயில்ஸ் எல்லாமே அதில் சேவ் ஆகிருக்கும். ஸோ அதை நம்ம வேற எங்கேயாச்சும் வேற இடத்துல இருக்கும்போது கூட நம்ம பண்ணி பார்த்துக்கலாம். இவங்க இங்கே அட்டென்ட் பண்ணியிருக்காங்க, இவங்களுக்கு இந்த ப்ராப்ளம்ஸ் இருக்குது அப்படின்னு கிளியராக நம்ம தெரிஞ்சுக்கலாம். ஸோ அதுதான் அதுக்கு இது யூஸ் பண்ணுறோம். இது மூலமாக 24 ஹவர்ஸும் ஹெல்த் டிசீஸை க்யூர் பண்ணுற டெக்னிக் கிடைக்கும். ஸோ அப்படி யூஸ் பண்ணிக்கலாம். 24 ஹவர்ஸும் கிடைக்கும். அப்புறம் வந்து அந்த டாக்டர்ஸோட ட்ரீட்மெண்ட் வந்து அப்படியே சேவ் ஆகிடும். அந்த இதை ஒரு சர்வரில் சேவ் பண்ணி வச்சுப்போம். ஒரு பேஷண்ட்டோட இதை ஓப்பன் பண்ணாங்கன்னா இவங்களுக்கு இந்த நோய் இருக்குது, இவங்க பிளட் டைப் முன்னாடி ஃபஸ்ட் டெஸ்ட்டில் எப்படி இருந்துச்சு, செகண்ட் டெஸ்ட்டில் இருந்துச்சு, க்யூர் ஆகிட்டு வராங்களா இல்லை இன்னும் நோய் போயிட்டு வராங்களா அப்படிங்கிறது தெரிஞ்சுக்கலாம். இதுதான் RFID டேக் வந்து இது வந்து ஹெல்த் சென்டரில் சேவ் ஆகிருக்கும். இது சர்வர்ஸ் ஐடென்டிஃபை த பேஷண்ட்ஸ், உங்களுக்கு என்ன இருக்குது அப்படின்னு ஐடென்டிஃபை பண்ணிக்கணும். அப்புறம் அந்த பேஷண்ட் வந்து க்யூர் ஆனதுக்கு அப்புறமும் மறுபடியும் ஐடென்டிஃபை பண்ணிக்க இவங்க எப்படி இருக்காங்க.
Finally, second, good approach. Make this in real time. Try to make the same in real time. Work hard and do some projects with this. Start making projects with the same way.
Simple, how to focus on RF and along with IoT. What other tools can be used IoT for the healthcare domain? First you have to study the more about journals, journal papers. You have to do some analytical survey on this particular domain. You get to know all the concepts.
Good. Department of Biomedical Engineering from Wales University, and I am here to present my paper, Technical System for Diagnosis of Gastroparesis in Diabetic Patients. Gastroparesis. Gastroparesis is a digestive disorder in which your stomach is unable to digest the food. And the main cause of the gastroparesis condition is diabetes. The diabetes influences more in this condition. People often get into this condition because they have more amount of glucose stored in their body. Once this condition happens to the patient, they fail to diagnose this because gastroparesis is diagnosed using multi-channel electrodextrogram, in which these gastrogram devices are not present in the hospital. Only Mayo and Pembroke Hospital are having this instrument, whereas most of the hospitals or research centers they don't have this gastrogram. So in this paper, we have decided to diagnose the condition called gastroparesis using multi-channel electrodextrogram as well as breath analyzer and also using gastric emptying.
literature survey. First paper explains that they have taken single channel electrocardiogram and have correlated with gastric emptying test. Single channel electrocardiogram in which they will take only active electrode and one reference electrode, which they will be able to acquire they can be able to acquire the gastric signal, and they will correlate the gastric signal frequency values with the gastric emptying test. Secondly, it's the theoretical analysis of a gastrogram, in which they have designed a male phantom, which means a male model. In that they have simulated electrogastrogram signal, in which they have drawn a triangle called the triangle called Hinton triangle, in which the dipole of two sides of the triangle they will submit and equal, so that they will be able to find the digestive rate of the phantom. And in this paper, they have designed an acquisition device for electrogastrogram single channel. No one has designed multi-channel electrogastrogram because it is very tough to extract gastrogram signal from the stomach. Because in this system, when you design a multi-channel electrogastrogram, there will be more signals influencing, like respiratory signal will be often influencing, and heart ECG signals often will be dominant signal. So it is very tough to extract a particular electrogastrogram signal. Finally, variation of gastric emptying in 3 stomach regions. They have selected here 3 regions in the stomach. In that particular region, they will take the biosignal of this electrogastrogram and they will correlate with the gastric emptying test. All the gastric emptying tests they have performed from the olden days, they are using scintillation method, in which scintillation crystals are being used. Once the radioreceptor fixes the scintillation crystal, the scintillation crystal will convert it into a pulses. So total amount of pulses will give the total amount of gastric emptying rate. Methodology.
Any recent papers you have reviewed?
Sir?
Any recent papers in 2017?
2017 have not reviewed. System one is the multi-cell electrogastrogram. We have designed multi-cell electrogastrogram, and other unit is electrodes. The first thing is electrode. Electrodes are used to pick up the biosignal. We have used disposable electrode and we have placed in the multiple region in the stomach, where I can be able to get multiple signals of the stomach. Whether I don't leave any particular signal from the stomach region, starting region to the ending region. From fundus to cardia, I don't leave any signal because I need all the depth information of the stomach, where I can be able to accurately predict the gastric emptying rate of the subject. Secondly, breath analyzer. Why the importance of breath analyzer is
this ESP detectation. You use national insurance.
NI is costly. I have automatically used the TMI system. One of the company we have approached, they have made a TMI system about it.
Multi-channel machine. How many channels?
I have used 6 electrodes. 6 places I will be placing the electrode. Why I am placing the 6 channels is I need to track all the path traveling by the inside the stomach. The food is being starting from this region, from fundus to cardia. The food is being completely traveling inside the stomach. So I need to trace the path of the food, whether it is completely digested.
All the 6 electrode is having same sampling rate or different?
Same sampling rate.
Same sampling.
Same sampling.
Let's say kilohertz. Kilohertz frequency of the signal.
Frequency of hertz. Maximum it takes 5 hertz and it's an average of 0.5 hertz. 1 to 0.5 hertz is an average of electrogastrogram signal. Maximum it will be take 5 hertz, not more than 5 hertz. Fine. Second system is breath analyzer, and the main use of a breath analyzer is we need to test the breath of the subject. Why? Because the diabetic patients, they will be having the breath of fruity odor in the breath. So if they are not taking the proper food and regular interval, they will be producing fruity odor in the exhalation. So we have designed the system so that the fruity odor of the diabetic subjects have a particular gas called acetone. So we need to find the acetone level in the breath. So through the forceful exhalation of the diabetic patient, we will be finding the acetone level of gas pressure inside the stomach. So once the food is being entered into the stomach, the food is being converted into ketone particle. Ketone particle again it will be converted into acetone. So this acetone gas will be produced, and this acetone gas will be detected by this breath analyzer. So for this system we will be using MQ138 sensor. It is a costly sensor. It is used to detect only this formaldehyde acetone gas level. System 3 is under processing. We have not constructed, but we have proposed a model and we So we are using a photodiode. Mostly in hospital they are using gamma camera, CT machine, SPECT machine, PET CT and all they are using. Here we are using only a photodiode. How can a photodiode able to detect the radiation? Photodiode is normally used to detect only the light particles, but this particular photodiode we are using BPW34, and this particular photodiode can be able to detect the radiation also. It is highly sensitive to radiation. So this photodiode will be detecting the radiation emitted from the stomach, and these radiations are converted into pulses. So that how many amount of pulses we are getting, we can able to calculate the digestion rate of the subject. So once the food enters into the stomach, it will be producing the pulses, and these pulses are counted like a counter. So 120 minutes the food is being completely digested. Once the food is being digested, all the radioactive particles will also be digested. So there will be no radiation produced in the stomach. So we can able to accurately calculate the gastric emptying rate.
System 3 is completed?
No, we have designed system 3 but we have not tested. We have tested KCL solve because it is also a beta emitter. So whether it is detecting the beta particles, this particular photodiode can able to detect alpha, beta and gamma.
You got the ethical rights for testing system 3?
So no, sir, no.
Without ethical rights, how would you test this?
Just KCL start from the laboratory I have taken and just we have measured that whether it is being detected or is being counting the rate. Whether there is a change of any counting rate or it is still the same milliwatt is being produced. So if I am using 1 gram of KCL salt, whether the same 1 gram of KCL salt placed on the diode, whether the milliwatt produced by that photodiode is 0.1 milliwatt, if it is been increasing or it is in the same level. If it is increasing rate, then it is detecting the particles, beta particles.
Have any architecture for that?
This is the block diagram of the system one. The electrodes has been connected to the instrumentation amplifier 8620. Why particularly 8620 is through the literacy survey we have all used the 8620 instrumentation amplifier because that instrumentation amplifier is noiseless and exact signal of the exact raw signal has been amplified. Why? Because the raw biological signal we extract from the stomach, it has been in very low millivoltage. Not to amplify this, we are using this 8620 and this filtering part. Why particularly after amplification we need filter is 2 types of waves will be extracted from the stomach. One is gastric wave, another one is gastric slow wave. What is this gastric slow wave is? Once the food enters into the body, the food will rotate 3 times in the stomach for 1 minute. It is called counts per minute. It will be taking 3 cycles. It will take for 1 minute. It have to take 3 cycles. 3 ring-like formation will be formed in the stomach for 1 minute. It is a normal. But in an abnormal cases or for a diabetic patient, the food will not contract or the food will be paralyzed stomach. The stomach will not even contract. The food is during a stabilized phase. So in order to get the gastric slow wave, we will be using this state variable filter. The state variable filter is a combination of high pass, low pass and a band pass. So we need only high pass and low pass to segregate the high pass signal and the low pass signal. We don't need a band pass signal. So why this state variable filter? Another advantage is we can able to get individual signal without affecting the filtering characteristics of filters. And through that we will apply the signal and the display device is your PC. This is the electrode placement region where we will place electrodes.
Go back please, 6 electrodes please, I can find 4.
First, second electrode, third electrode, fourth electrode, reference, ground we will take. This is the working model we have designed and tested. It consists of application instrumentation amplifier, high pass, low pass and band pass filter. And the band pass filter and notch filter we will not be using. We will be using only high pass, low pass and amplifier. Amplification is set to 100 dB. Why? Because at that particular point we can able to get the exact electrogastogram signal. All the literature review we have followed that they are getting 100 dB. In that particular point they are getting the exact raw signal of the electrogastogram. So we have selected 100 dB. And the procedure for getting
any one subject voluntarily, he has to go for fasting 2 hours. There should be no food inside the stomach. He will be take the signal, and after eating, after 2 hours of eating, we will be taking again signal for the subject, so that we can able to differentiate whether the signal variation in the subject. And this is system to breath analyzer, in which we are using a flow. This is a simple kit we have used for a breath analyzer, in which here we have gas chamber. The gas chamber contains MQ underweight sensor and digital temperature sensor, in which the calibration of the sensor, gas sensor is purely based upon the volume of the gas chamber. This is a simple, not exact gas chamber. It is a prototype we have designed gas chamber, so that the calibration involves our volume of the, based upon the volume of the gas chamber, the sensor is being calibrated, in which the gas chamber, the flow pipe, the forceful escalation gas of the subject is being blown, and from that gas we will be able to detecting the ppm parts per million of acetone level present in this breath, and it will be shown in the LCD.
System
This is system 2.
Both implemented.
Both implemented. System 3 is System 3 also. These are the values we have been get through the breath analyzer values. Whereas if you see here, subject 1 at fasting state, where there is no food, he has 17 ppm, which means he has diabetes. Normal range of ppm rate of breath acetone is 1 to 5 or 7, 1 to 7 or 1 to 5. But blood acetone value, where if you give blood test, they will check acetone in the blood also. It will be in a negative range. Whereas in the breath, if you are measuring, it will be in a range of 1 to 7, maximum 7. If he is having 17 ppm, means he is having a diabetes, in which without food he can able to produce the acetone gas. How it is, the stored fat molecules inside the stomach is being converted as the acetone gas. So without food also, he is being completely digestion is being carried out. So getting 17 ppm. After fasting state, post-prandial, we are having 21 ppm, which is more than the fasting state. Yes, surely he is having the condition of gastroparesis. This is the radiation detector job design, but we have not tested the radiation detector. The main circuit is this, where we have BPW35 photodiode, and this is a simple amplifier. We are using BC5496 transistor. It is just a simple amplifier and a counterpart. It will be amplified and it will be counting the pulses, but we have not tested in prior to the hospital, because we have to test only in the hospital. We have to give proper permission. Once it is being tested, we can implement this photodiode in the CT machine and in any other detecting machine as a radiation detector. The correlation of first two systems, we can able to get the not exact values, but we can able to correlate the values of MEGs, multichannel electrogastrogram frequency values, as well as the breath analyzer values, so that you can able to predict if the patient is having gastroparesis condition or not. But once the third system is being tested, we can able to confirm that he is completely having this condition or not. Once if the patient is having a gastroparesis condition, he is directly forced to take multichannel electrogastrogram or gamma cam or PET-CT in the hospital, which costs around 50,000. But if we implement this thing through signal processing, we can able to confirm that it will be a confirmatory test. Whether if he is having gastroparesis, we can send the patient for the image processing, or we cannot. We don't need to send the patient for the camera processing.
Success rate of what is the success rate in the accuracy?
Accuracy rate we cannot. Based upon both the system, we cannot able to exactly say that this will be working on. Based upon the we have to take subject, because some subject will be having diabetes, some subject will be having not. They don't have diabetes, but they will be having this condition. So accuracy cannot be predicted at 100%, but we can say that it will be working on 60% to 75%.
Is there any results?
This is the frequency plot of the subject with respect to fasting state in class. and fasting state and post culture. This is frequency plot, and we have seen that
this y-axis
frequency in hertz. I have not mentioned it. Frequency in hertz, 0 to 4 maximum. As I have told earlier, it will be around 5 to.
From this graph, subject 4 and 5 are having the problem.
From this graph, we are seeing that subject 4 and subject 5 are having the gas basis condition. The waveforms are prolonged, but when you see that breath and laser values, subject 4 will be having gas basis, subject 5 will be having a normal one. So the prediction rate is, we cannot able to confirmly say that they have this condition or not. Subject 4 is having gas basis. With respect to waveform, it is confirmed. But subject 5 is having a normal rate, but whereas in waveform rate, we have prolonged waveform. We have the tachygastria and bradygastria. Like heart rate also, in case of BCG, the TQRST waveform, if it is an extended waveform, we will be saying that it is a bradygastria. We have so long ECG waveform. So in here also we have the tachygastria, bradygastria, prolonged gastric waveform also, we will be saying that he will be having gastria.
What you have planned to modify to rectify this problem? What is your plan for rectifying and
accuracy should be maintained in the filtering part and in the that part. Sampling rate should be checked, filtering and sampling, so that we will be getting accuracy.
What stage can you confirm this gasobasis? What stage? Gasobasis.
Starting stage is once the food is entered into the body, you cannot be able to digest for 2 hours. So 2 hours you don't feel anything, the stomach rotation, or you don't feel any nothing. It will be like paralyzed stomach.
Slow digestion.
Slow digestion. Only after the gastric diabetic patient will be getting this thing at the age of 42.
What are other symptoms? Other symptoms.
What's slow digestion? They will be very much hungry. Even after the digestion also, they won't feel nothing. They will feel like, I have not eaten anything. I want more. Because the food is being dumped in the stomach. There is no feeling at all. The stomach muscles are paralyzed. This condition is called stomach paralysis. The stomach muscle is paralyzed. We will be getting fruity flavored order often.
Good afternoon, all present over here. I am R. Chakravarti and he is Prakash R. We are from Department of Computer Science Engineering, Veltech Multitech Cse, and we are presenting face recognition model using back propagation. The main objective of our paper is to increase the efficiency in face detection. Nowadays we have face detection in Android phones, in banks, everywhere. In many areas we use face detection and face recognition, and our only aim is to increase the accuracy and to increase the efficiency of face detection. In olden days, due to the variations in viewpoint, illumination, facial expression, etc., you can see the various variations in your face, and due to it, it was very difficult for, in olden days it was very difficult for developing a facial recognition software. But nowadays, due to the development of the deep learning neural network, it has been far easier. And we use, in this project, we use back propagation neural network and deep learning convolution neural network. That is, back propagation is, once the output is given, the output is again given as an input. The output comes along with the errors, and those errors are given again as an input to rectify it, so that the maximum accuracy can be attained. Face recognition algorithm uses SCAT. This is the existing system nowadays what we are using. Face recognition uses scattering convolution network, and it is locally invariant. The main comparison of the proven system and the existing system is PCA. For this, they use the principal component analysis, and they use the SPM algorithm. That is the vector vision algorithm. And the next step in existing system is they'll test it using edge map, 8 phases, and SRC. The accuracy of this existing system can be improved by rotation translation invariant scattering features. That scattering features may be rotated or translated. In an image of your face, a rotation and translations can be made and the accuracy can be improved in existing system. Next is the disadvantages in this existing system. Why we took our paper is because of these disadvantages. The maximum what you can get is 93.1% of accuracy using the existing system, and it has this automatically you may know due to 93.1%, those 7.8% is a loss, and if anyone can breach your face. Identical twins can breach their brothers and twins accounts like that. It has less efficiency. You can already see 93.1%. Our proposed system has 98% of accuracy. In our proposed system, we use convolutional neural network, and the image classification task is done by Python script. And what are the packages we include is TensorFlow package and Keras high-level neural network with back propagation algorithm is used. The TensorFlow package has the algorithm, back propagation algorithm, and we include it and we use it. In this algorithm, when the output is obtained, that is I said back propagation method, the output is obtained along with the errors. That is, in the existing system we get 93.1% along with the 7.8% of errors. Those errors are given back again as an input, back propagated again, and it is again same testing and analysis is done, and with the errors rectified, a new output is obtained with increased accuracy. Advantages of our system is it provides high accuracy, which is 98%, and it has automatically you can see when it is 98%, you have high security and efficiency, even the identical twins can't breach your account. And the next is, in biometric support and facial recognition, everywhere this can be trusted in use. This is the literature survey what I did in past papers, who all did research in this criteria, they all got only this recognition rate, this accuracy only they got. You can see the maximum itself is 96.56 radial basis neural networks. They proposed radial basis neural network and they got an accuracy of 96.56%. But using back propagation method, we can get 98% of accuracy. This is the architecture diagram. We are doing a training set. This is a training set. Input faces are given as images with different expressions, variations in the expression faces, and pre-processing is done. In pre-processing, we do all the training etc. And neural network with back propagation is done in the next step. Here is where the output along with the errors will be got, and it will be again back propagated till it reaches a maximum of high accuracy. Finally, the classified face is well known. Data flow of the diagram is we are capturing an image and we are detecting the features and features of the faces, that is the variation points of the faces, and a training process is done for the model. Neural network is a process, a deep learning and neural network are processes which has infinite learning. Whenever you keep on updating, it keeps on learning and training the database. All those information what you train are saved into the databases, and testing is done whether to check it is working or not, and the results are produced. These are list of modules. In this process we have 4 modules. First one is the pre-processing module, next is the neural network module, next is the training module and testing module. First we'll see about the pre-processing module. In this module, we are converting the PNG image to the required PGM image, that is grayscale image, gray map, portable gray map, which should be easier for us to process. And these images are given as input and they are stored in buffer as bytes, and they are further used to find the values of the header, width, height, maximum value of the image, etc. The maximum value of the images will be 256, and now these converted data are stored and now the bytes are converted into data. These bytes, image bytes, are converted into data for further processing. It includes calculation of dimension of image, which is in the matrix form. We are representing it in the matrix form like 112 into 92. The dimension of the image is given, and for further simplification, we are taking since it is to be, the input is to be given as one row. It will be given as one row into 10, the 3 or 4 vector. It will be converted from this matrix to one row of matrix, one row full of data. Then the PNG image will be processed to the next module to the neural network. Next. This module snapshot is, we are including the TensorFlow package and the Keras version. This is training set where 3000 images are given for 10 classes. We are creating this 300 images per class. which gives 3000 images for 10 classes. Then for validation purpose, we have to compare and match, right? So for that validation purpose, we are giving 40 images in 10 classes, which is 4 images per class. Next is deep learning and neural network module, which is the important module in this. First, pre-processing model, we have given the inputs and we have converted all the data and sent into it. In this module, the data set are processed by convolutional neural network in which different features of the images are observed and respective weights are assigned, which is the important one. The respective weights are assigned to the variation points in your faces. And on which basis you assign the weights is padding of the image, pooling of the image, overfitting of the image and dropout of the image. Using these categories, criteria, we assign the weights to the image, and after assigning the weights, we move on to the process. Neural network with multiple hidden layers are called deep learning. Deep learning is done. And advantages of deep learning is we no need to worry about the features of the data set. The accuracy is too high in deep learning and learning does not stop. As I said, learning will never stop. It is a keep on going process where deep learning, it keeps on learning. It learns by minimizing the errors. As I said, back propagation is done and the output is obtained with an increased accuracy. Further errors minimized by back propagation. This is a very good example. You can see this car. It may or may not be Audi A7. I am saying, mark my words, it may or may not be Audi A7. May means it is definitely Audi A7. May not means it is not Audi A7. So may not are along with errors, which may not be Audi A7. Those errors are taken and deep learned in this. And once again, in this also they cannot, with high accuracy we cannot say, if this is 90% of the accuracy, this will be 93% of accuracy. This will be 95% of accuracy. This will be 98% of the accuracy where you will definitely say it is Audi A7 or not. So you will recognize an image whether it is particularly that image or not. High efficiency is given. This is may or may not be Audi A7. This may or may not be Audi A7. But in this, it is definitely Audi A7 or not, you can say. This is how the deep learning and of neural network works. You can see how based on padding, pooling, depth, density and convolution, activation, maximum pooling, everything weights are assigned. This is a snapshot of the module. This is the next module 3, which is the training module. I said deep learning, it is a long-term training process where we have to train it and it will learn along with this. In this module, 3000 dataset images are given for training to the model through 10 classes, which each class has 300 images. Along with the training module, validation of the image is also done. I said for testing purposes, we are having another set of modules where 4 images per class is given and 40 images for 10 classes are taken. This module trains the images by randomly selecting one image from both the training and validation datasets. It takes one from this image and one from this image. It compares both and sees whether it matches or not. The training module provides the high accuracy recognition of faces, about 98%. You can see here, it is clearly viewed. Here we have, it takes 12 seconds and it is 0.1, the accuracy is 0.1750 within 20 back propagations. First time it is 0.70. With the errors are given again as an input, second iteration it will be the accuracy increase. You can clearly view how the accuracy increases with each iteration. Every time the data errors are back propagated, finally you can have 98% of accuracy. The accuracy snapshot, final results is found 50 images belonging to 10 classes. The average list accuracy for 50 images is 97. That is approximately 98%. Module 4 is testing module. Now we are done with the accuracy, 98%. We have to know whether this is working right or not. So for that, in this module, the testing is done to check whether the model's prediction is correct or not. The test again, we are creating another data set. Another data set contains 10 classes for each containing 5 images of a person, which gives totally 50 images. The testing is done with the output of the training module and the testing data sets images. This module predicts the class of the specified image correctly by comparing it with an array of classes. I'll show you the next slide with the program. First, we'll have all the variations of the images in one class, and we'll do all the classes, and it will compare both the class and exactly say which face is it. You can view this image. This image will be present in any one of the class. This image will be in any one of the class. Next slide. I have listed all the classes. I said 10 classes. Class 1, class 2, class 3, class 4, class 5. I have listed 10 previously. You can see this image and next. This image, both are same, but of different different lightings. Next. Same code is run with a different image, but the same class is given. You can see how accurate it is to find the face even when the lightings differ. This is the overall process. You can see training and testing are running simultaneously, where training is done with the feature extraction from the faces. The variation points weights are given to the variation points and they are taken. And the feature database training with the 10 classes of 3000 images are done. They are saved in the database and trained the latest here, present here. When we validate, that is for the testing purpose, we are passing another new data set. And the new data set, simulation is done along with the both, and matching and recognition is done, and 98% of accuracy is achieved. This is not so complicated. It's very simple. Intel Core processor is used. 4 GB RAM is enough, and system type of 64-bit operating system is enough, and Ubuntu operating system is highly enough, and GPU and CPU machines are enough. Software components are programming language. We use Python. Packages, TensorFlow package and Keras package, which is open source. It is available online. And development tool is iJupyter Notebook. It is also an open source, available online. Everything is open source. These are the references I took, and I submitted. Thank you. I need to conclude that this is a best approach for a face recognition system, but it has a slight drawback, that is, it will take some time for recognizing the face as it has to go through the overall checking. But the security is it is guaranteed for sure. They cannot breach the security since it is 98% of accuracy.
So your presentation is